Okay, I think we're getting close to being done here. Live streaming, what did it do? Oh, it started that. Here we go. We have 3 concurrent viewers. Excellent. Okay, that's really what I wanted to have shown when everybody got going. Welcome to my little orange can astronomy thing. I probably should show you, what the orange can thing is all about, which I should go back here just a second. It's called the Orange Can Astronomy because, well, this glamorous fellow here, he has this orange can attached with all the equipment and other junk. That's how it kind of started. This is up at my father-in-law's place, and he basically had a spot out in the field. This is only about 50 feet, maybe 100 feet from his house. So, well, there's bathrooms and a warm-up place, things like that. So the original orange can, this is first light. I have to start with some of these pictures. And yes, I've lost a little weight since then, but this is first light of the thing. And this is a Celestron Nexstar SE8. It's a wonderful telescope if you're looking for a beginner with a decent amount of aperture. The optical tube itself is pure Celestron. It's probably, designed back in the 70s or something. You probably can't go wrong with it. And it's also got attachments for the fast star stuff. So if you wanted to put a hyperstar attachment or something like that in there, you can go ahead and do it. Since then, I got into a little bit of astrophotography with the old setup. The SE mount is great for viewing and whatnot, but if you get any little bit of wind, this single arm mount just wasn't quite enough to handle it. So we ended up upgrading the mount, like everybody does, to an Ioptron. This is probably a good picture of the mount. An Ioptron AZ Mount Pro, which is my current mount. It has all the Vixen things here. So you basically take the optical tube off of the SE, plop it in here and turn it on. And it's got GPS and everything else known to man. I enjoy using it. It's as easy to use as the Celestron. And this is a picture, a movie or whatever of it doing the alignment, which is completely automated. It's got GPS and stuff in there. So the current setup with cameras and stuff looks more like this, which is still the orange can like before. I've added a moonlight focuser, which frankly I've just taken out of the chain. It's a wonderful focuser. I can't tell you enough nice things about it. But that's the focus. I kept it around, so if I do some optical sessions, or visual sessions, I can take that out and put it back on there. It's just it just screws on. And then this is the DSO camera that I didn't have out last night. This is a ZWO ASI 294 MC Pro. Sounds really important and really long name, but it basically means it's the cooled version of their 294 camera. Tends to have a very deep pixel well, so in light polluted Ypsilanti, it makes it great for taking images and then chopping off all the nasty stuff you don't want. Recently, I added a Celestron motorized micro focuser here, which it basically I was delighted to find out I could still use the moonlight focuser. But for doing imaging and all that, the motorized is super fantastic because you can adjust the focus on the fly. And without bumping it, and even if things are out of focus when you're doing your setup. So this is more or less what I had set up this afternoon for the solar, my plus a solar filter. But because right now is super cloudy and it's looking kind of nasty, it really wasn't a great night to be doing any kind of looking, visually, imaging, etc. So right now they're saying that it is 5% cloud cover, which, well, if you can't see the stars, it's cloudy. transparency is saying it's awful and seeing is below average. So it really wasn't a great night to be out. So in lieu of going out, we're going to stay in, and I'm going to take a look at all the images that we took. Oh, this is from previously. I'm going to take a look at all the images that we took yesterday evening or last night, and probably a solar one or two. So without further ado, I don't need that anymore, I don't think. I don't know why that's showing differently. That's kind of weird. Oh, that's Studio One. Got it. Okay, so without further ado, this is, I use SharpCap, and SharpCap has a neat feature, which we can go into SharpCap real quick. I have a very slow PC here. I normally run Macintosh machines, but frankly, the astronomy software for the Macintosh is not all that great. But whenever you capture something, there's this target name up here. Let's do still webcam. That's fine. So whenever you capture, oh yeah, whatever. No, I don't want to send. It's going to quit anyway. It doesn't like the webcam apparently. Whenever you set up, it basically forces you to name whatever object you got up there, and you can type into the block. We're just going to choose a test camera. That always works. So you can choose from one of these or type in something like Orion Nebula, whatever. And that label that you put in there will end up translating into one of these things in the directories. SharpCap always puts the date in the directory, and you can configure all this stuff. But I did imaging on September 25th and 26th here. Obviously, the 26th is going to be the sun, and well, Neptune was the last thing last night after midnight. But most of our planetary stuff is going to be in the 25th here. And these are the ones I got good pictures of. Neptune, by the way, did not turn out, so I'm not even going to look at it. It's I didn't realize it, and this is going to give everybody a little bit of laugh. Never say I didn't have a little bit of comedy routine built in here. We can quit out of that. But my normal setup, I bring everything out. If it's going to be night, I have the dew shield up. That I was setting up last night. We had a series of problems come across the way, and I kind of started a little late, so everything's a little hectic, and it was a little abnormal. Well, all right, I'm imaging away and I'm having a good time. We had good discussions last night. It was actually a really good session. One of the better online sessions I've had, even though there was only a few people. They asked a lot of questions, and it was a good deal. And along comes Neptune, and I'm talking it up and telling how blue this thing is compared to Uranus, which we had just seen. And I get to Neptune, and it looks like it's almost as gold as Mars or Saturn. It's like, what the heck? What's going on here? I messed around. Maybe I got the wrong target, checked star charts, checked this and that, played with gain, did everything I do. It's like, no, that's the correct place. All right. And then when I was breaking down after midnight, I noticed underneath the table, there was the dew shield. So, and I looked in front of the telescope, and sure enough, it's all fogged up. So we were looking at Neptune through the fog of dew in Ypsilanti, Michigan. Lovely, just lovely. So with that, basically when you capture stuff, it's going to classify them there. And then of course it gives you either, if you saved individual files, like this one here, let's give, I love how Windows always assumes you want icons of everything. It gives you a couple of things, which is really nice. First of all is the meta file variables that were used when you capture. And these are useful when you're trying to label stuff like, I don't know what the heck gain I used, or what the exposure was. Well, this stuff tells you all that kind of information. Oh, sorry. the gain, there's various rates, the white balances, all this kind of individual information, as well as well up at the top what camera you used and the timestamp and version number and stuff. So it's basically got everything you needed to know about this directory. And if you didn't do directories and used like a SAR file or something, you'll have a matching. So you got the like here, the 21, 23, 22 camera settings. There's a histogram CSV if you want to see it in Excel. I don't know why. And then the actual SAR file, video file, or in this case, it's a directory full of stuff. The Jupyter, the TIFF files, you can actually see, but Jupyter was frankly, it wasn't that great last night. And so I kind of cut it short because normally we get thousands of these things. These files, individual ones, they take too long to write out, which is the reason that we use a video to start with. So I kind of stopped this after a dozen frames. It had already gotten like a couple hundred failures. So it's like, this is going nowhere. And the SAR files are just more useful. They still show up, which they look horrible. They don't look like anything. And you can view them as a video. And remember, videos, just like in the old capture days, they're nothing more than a series of frames. And you can see here this video, it was 1920 by 1080. It was a 16-bit. They use 1 bit for others. It was about 8 frames a second, which is about right because I was at full resolution, or near full res, and I had about 971 frames. Now that looks pretty blurry and pretty awful, and occasionally it gets clear, but it really wasn't that great of an image. But we can let this play back. It doesn't get any better really. But it's a nice thing to start with because it'll show us some difficulties in some of these areas. I really got to get rid of this little frame thing, put it off to the side. What a pain. So we're going to get this out of the screen. We don't need that. That just takes up bandwidth. Some of the other files a little better. This, so you can see the focus was a little better. And I think this last one might, this is a moonshot. Great. That doesn't belong in the Jupyter folder. Guess what I did? I forgot to label that one. And so we'll do a moon one. So we got a couple of Jupiters to work with and a moon. And I'm just going to go through the process of what we do. Is like usually I'll spend a night gathering various files and whatnot and capturing stuff. And then the next day, or for weeks on end, perhaps, I'll end up post-processing these things. Generally, the planetary things are pretty easy to deal with, but sometimes if you get thousands of frames, the programs choke on them and die. So you sometimes have to do it a few at a time. So without further ado, I'm going to introduce you to our next star of the show, which is a little program. I don't know if you can read that. It says AutoStackert 3. And it's AutoStackert 3. Dumb name. But it's Dutch and it's free. So the price is right here. And so like you'd expect, they kind of guide you through the steps. And the first thing I'm going to do is open our SAR file. And so we'll go desktop. And this is because I wasn't a Windows expert when I did this. So everything is in the desktop of a default user of some sort or another. And I think this first one was, yeah, that's the 1990s. Okay, this is the Jupyter one we were looking at just a second ago. And so here we go. This is the image. It looks, wow, unimpressive to say the least. I think we can do a fit to display somewhere. Where was that? Maybe not. Maybe it's the other program. Doesn't matter. In any case, the first thing we do, because all of these things need to do some kind of analysis of the thing before they run. And the purpose of this program, as the STAKK might indicate, is to stack these frames, which is basically literally taking each frame, adding them together in a way, maybe deciding that some of them aren't good. Oh, excuse me. And then getting, what that will do is enhance any details you have. It will take out all the frames that weren't worth a hoot. allow you to change your percentages that you're going to accept, etc. And that's what some of these blocks up here are doing. This is leftover from last time I ran it. So first thing is this is a planet, obviously. Dynamic background, that's just default. I leave it. These defaults are actually quite reasonable. Most people say don't mess with the defaults. They work just great. And so we're going to just say analyze. So it's going to take that thing and basically run an analysis through things. And this can vary in time depending on how many frames you got. We took about 2 minutes of video. Um, as I mentioned last night, Jupiter, because it rotates once every 9 hours, it's spinning pretty quick. That you basically have got to limit how long that you expose your camera. Otherwise, you could get smearing to happen. So I took 2 minutes, which is well under the 3-minute rotation speed. I want to say technically it's like 3 minutes, 20 seconds, but everybody says if you get close to 3 minutes, you're going to have smearing happen or the stack will get fuzzy, what have you. And I've had a lot better results going with 2 minutes worth of video. So after you analyze, it comes up with our graph here, and this is basically the sorted line of the quality, if you will. And generally, wherever this crosses 50%, that's where I was cutting off before for like what I would put in here. Oh, excuse me. Late night last night and a long day today. This is one of those controversial numbers to put in. Like this one, I was trying out all kinds of stuff, so I had numerous things going on here. A good friend of mine and a very good imager, Auni Hafed, he did the H alpha solar sessions in both days. He is a strict 15%. That's all you got to get, which is way back here, which is definitely on the high end of the quality. So it's the top 25% roughly of your thing. And, in this graph, that's, 10, 15%. These are quarter. So, well, this is going to be probably around 10%. If you go 15, it's going to be around here. So those are pretty good quality numbers. And just for illustration, we'll do his numbers, and where I see, if it crosses here, obviously it dipped in quality. So maybe we'll back off on that a little bit, maybe, include these things. So we can mark that green line there, and then we go over in this window, and that will say it's 50, the top 53.8. So say 54%. So in here, we're just going to put 54 instead. So it's not quite at the 50% line where it crosses over, but yeah, it's pretty close. And then, this normalized stack, this basically will change the brightness of the thing so that they're all the same brightness. So if you had like a cloud go by or something, this will basically bring all those pixels up to, their average value. Double stack reference. These are all defaults that I think that have been in there before. Aligning the different RGBs. Those are handy because if you think about it, you're looking through the atmosphere and you're looking through layers of air, and whenever different light comes at different wavelengths, it's going to change that slightly, and it'll have different shifts. So you'll actually receive the colors in slightly different times. This is basically a mechanical computer way of dealing with that. So that's a good thing to do, is to normalize that into RGB align. That gets you in here. You can basically make a note and maybe say this was the fuzzy Jupiter, not the better one. Drizzling, people have had good and bad luck with it. It basically will intersperse pixels as it sees fit. I don't bother. So we're kind of ready in this panel, but you notice it's not ready to stack just yet. And that's because it doesn't know where to align things. So let's move this over a little bit. And this basically is a place where you can say how many alignment points you want to get. And this is the size of those areas. And you'll see we can choose, let's choose 48 and see how many points we get. So this will stick 48 points, and they're about that size. Is that enough to keep the image together? Yeah, probably. So we can go with 50. That gives 154 alignment points. That's probably not bad. There's that zoom. So you can zoom in, zoom out if you need to choose. It really doesn't make too much of a difference. 100% is fine. And so now after we've chosen the alignment points and we've got those set, guess what? Stack is right there. So we'll punch that, and this is going to go through the process, and you'll see it have progress down here. It's going to basically do a complete set for 15% and at 54%. On some of the larger files, this can be a significant amount of processing. And I mentioned before, is like my PC that I have here was a used one that I got for 200 bucks, and it's got lots of ports, which is great. And I have it maxed out on memory at 16 gig of RAM. I have a 1 terabyte solid state drive, which it's operating on right now, and a 1 terabyte normal hard drive, a spinny drive. Mainly it's like a backup partition. So after I get done with stuff, I can start with a clean slate for my capturing and back everything off to the hard drive. Eventually, I store things on it's the Blu-ray extended format, extra long XL, something like that. And those hold about 90 gig a piece. But you'll notice if we go over to our file menu, these files can get really large, the SAR files, which is not going to show me easily. So these were 3 gig, 4 gig for only 2 minutes of video. And those are cut down resolution. If we did those full resolution, like if we look at the moon, our Neptune, actually the moon was in there. Is that it down here? Yeah. You notice this size, 57 gigabytes or megabytes, sorry. So significantly different reading if you're doing full resolution. And remember, that's only 2 minutes. If you get the dark sky images and all that, they can be 2-3 gigs per image or 2-3 megs per image, and those add up fast. So this will take a little time to run through, and I'm going to take a quick look to see how our friend Bob is doing, because he's going to do a tour of the solar system with Space Engine. So I'm going to start his meeting, and we'll let him get going. So he's supposed to start at 9. And I'm going to just mute you guys for a second while I take care of Bob. Thank you, kids, for indulging me. I'm back here, and you can see our stack finished up. Both things are right here, and let's look back at what files it produced. So you see back down here, it added the fuzzy in there, which we probably should put some underscores or something like that in there. But what it produced, and we asked it to do a TIFF file up here, because frankly, TIFF or FIT are the two good ones. TIFF is nice because you can use it with Photoshop. FIT is useful for the next step. It will read either one, but TIFF is readable by everything. So, and it's a raw format, so there's no loss in compression or things like that. So let's take just a quick preview, which this is the nice thing about TIFF also, is we can look at this one, the 15%, which again is like, wow, that really improved things, Jeff. And then the 54%, which looks about the same. I expected a little bit different, but you notice that we got a blue background here. So this is evidence that it has been stacked. Compared to the raw, yeah, there's a little bit of something there. Okay, we've got it stacked. It doesn't look very impressive, I admit. But the other secret sauce is Registax, which we can bring up. And Registax can be used to stack. I don't recommend it because it doesn't do as good a job as AutoStacker, and it's 10 times harder to use. So basically, once it gets done getting ready, we'll select a file, and we're going to go back to our desktop. You don't have to do this every time, but the first time you run it for the day, it has to figure this out for its little self. And so we have two images. We're going to do the 15% one first and go from there. And then the first thing I'm going to remember, this is the wavelet feature. This is the last step in their little thing. You have to set dyadic because linear isn't going to get you anywhere. If you get, and these are both free programs, but this will allow you to basically play with the sharpening features on the thing. So I'm going to pause once more and get Bob started, and then we'll continue on and we'll let Bob float free and play with his stuff. So one moment, please. There we go. That's the last interruption tonight until somebody else does something silly at Astronomy at the Beach. Which thank you for all for coming. Remember, hit the like button, leave comments, and if you can, get to that survey that's at the AATB 20 website. So we're about to attack Jupiter with our Registax tool here. I'm going to scoot back a little bit so I can lean in. I don't know what you're seeing from the video camera. But these are basically two adjustments, and we have denoising so that you can add some denoising abilities to it. And this is the factor that's going to sharpen it. And it goes by even tenths or even 1/100ths of a percent. And then this is a slider, which is kind of like how much you're going to apply that 100% in kind of a percentage way itself. And this is the total number it's going to come out with. So if you look here, probably not a whole lot of anything. Not going to look all that impressive, but you can see it does change every now and then in very subtle ways, but it's not going to do a whole lot. And part of this is these wavelets all go at like the biggest pixel, the broadest areas first, and then it gets finer as you go down. And by the time you get down to 6, it's debatable whether you'll see anything at all. So a lot of times in this first one, I'll bump it up to like 110 or something, 105, whatever it does, and then add some in here. And it's a good idea to go kind of gradually. And this is not gradual actually. This first one, sometimes you just don't get very good results. I believe this picture was taken with a Barlow. Now, I don't know if you can see it on YouTube. Uh, I'll try to exaggerate, but around here, you see how it looks kind of grainy and almost like there's a sheen on it, a satin sheen. That basically is indicated that we've got too much sharpness going on. So we'll back off on this until that goes away, which I kind of overblew it big time. And sometimes this first one doesn't yield any results at all. It might be that we don't get anything. Jupiter was kind of foggy last night, so I'm not real hopeful. See, we're back down nearly like 5.4. That's virtually nothing, and it's still grainy. So let's just turn that off. We'll go to the second one and maybe bump it up to 110 immediately and see what we get. This is a very slow program, and I'm still not getting much. And see, we're already getting the grainy stuff. Now, this is partially because we used a Barlow, and it's a tad overexposed, but the Barlow is kind of pushing the limits of the sharpness anyway. So there's not much we're going to get with real fine controls. So let's go up to the third level and see what we get. Usually by 3 or 4, we start to get results, and I'm still not getting anything. You know, these are live demos. This is what happens. Yeah, you see here it starts even checkering in the middle. You can produce some really funky effects. But you do notice that some of the detail here is starting to come out. So it is doing something. Let's just forget 3 as well. It's not a good demo, but we knew that this one was going to be fuzzy. So that's why we labeled it such. Probably not a good first demo to use, but now there's a discernible thing. And you notice the moon popped up here. So we can add a little bit more to that. And we'll add that until it gets fuzzy, and then we'll back off a little bit. And then we can bump it up another 10 and see what it does. Sometimes it does something, sometimes it doesn't. It's hard to say. And you always go easy with the controls and back off once you notice it getting grainy. It's a good idea to pay attention. Sometimes you can use a zoom in feature where press control and it'll show you different areas. So if you're working in on stuff and you really can't tell whether it's grainy or not, this is the way to tell. And you can see up in this picture, yeah, it definitely starts to get a little grainy. So we'll back off. Maybe we'll stick with that 110. That worked pretty well. But we increased our detail here. So let's go at number 5, keep 4 where it's at. And look at that. That's amazing. It still has about the same graininess as before. Let's bump it a pinch further. Oops, that's 4. Wrong slider. And these are all kind of relative. You'll mess around with them back and forth many times. Maybe add another one up here. Sometimes if it starts to get on the edge of things, you can add a little denoising, and that can get rid of that. This might not be the right level. 4 might be a better place to use that, actually. And sometimes the denoising, you notice, goes a lot slower as far as the numbers. They go, 0.05 and all that kind of thing. And that can help. And you can sometimes eke a little more out of a particular wavelet that way. But you see, we're starting to get more detail coming out. You'll notice that there's a heavy blue tint to everything. It's got a nice balance to that. Now, I can say that this camera, the 183, it's got more blue bias to it, if you will. So I end up turning the blue down almost every time. Oops, wrong slider. Not sure what those sliders do, but I end up going down in the percentage here. And you see that turns it into a much more natural looking color. Because we know that Jupiter is not blue and it doesn't have a blue haze around it. It's kind of ruddy, and maybe it's getting a little too much green. We can reduce the green too. The histogram here can tell you a lot about that stuff. Auto balance is sometimes kind of interesting. We can do that and reset it. Auto balance is not recommended, but every one of these requires a redraw, and we'll bump that down again because it looks nicer that way. Because we know Jupiter is fairly brown. It's not green. It's not real red. So sometimes just reducing this whole thing, and that can help a lot. Reduce the blue out of there. You notice we're still getting a little bit of blue around the edges. We can fix that too. Woohoo! And that is the RGB align. So sometimes remember I told you about the atmosphere thing. Sometimes you need to adjust the thing. Like right now, the blue pixels are sticking down on pinch low. So we're going to bump them up 1 pixel at a time, take it up, and then maybe take it right a pixel as well. And you notice, look at that, some of the blue is gone now. One more. And maybe another one up. And that can help. Now you notice the red is a little bit up here. So we'll take the red down a little bit. It didn't really help much. A lot of it is trial and error and just mess around with stuff. So now we got a reasonable looking image. It's not looking squared off. These techniques, the denoising and the sharpening, those sometimes can give you flat edges. So that's a thing to watch out for. And finally, we're going to play with number 6 here. And 6 is one of those you kind of have to be careful with, because it can get some really awful looking stuff. Like if we did this over here, that's the kind of stuff that you can get, and nobody likes that. I'm going to check on the questions real quick, and yep, nobody's there. Okay, that's fine. Feel free to ask questions because I'm here for you guys. It looks like we got 14 people looking in. That's great. Be sure to use those like buttons. And let's stick that back to something sane. That's a nice thing, and it'll always start out from the original image and work with that, and that's why it takes a while to calculate all 6 of these things, and they're all additive. So maybe we'll give this one a little more severe tinge to it, like a 110, and see if that helps us at all. The red spot is strangely blue, and maybe this balance, we can increase the red a bit. That did not help. I'm not actually sure why that is kind of a bluish color. That is very strange. Jupiter was acting very strange last night. I didn't get the normal results that I get. Add some green. Nope, it is not teal. It's very unusual to see. Normally this is kind of a ruddy brown mess. And the storm is the red spot is actually a big storm hurricane that apparently is, I want to say it's 3, I think it's 3 high and about 5 earth wide. It's just huge. Let's try rotating that again. That is just, that's weird. Or adjusting. I think the red needs to be over. Something wrong with that. Oops, wrong direction. But you can see the different cloud layers and stuff. The blue color, that could be part of the California smoke. You never really know. Dismiss. Good. Our Ask the Astronomer event just finished up. Good. I'm going to let the guys know here. I don't have a tab for that. Okay, no matter. Notice how the moon is all is kind of smeared there too. It was jiggling around. Yeah, it's very strange. In any case, this is the kind of thing you go through. It's like after a while you mess with this, you mess with it, and it's like it's just not happening. The last thing is maybe try playing with this gamma tool, and this is basically like the I think it's the curves tool in Photoshop. It's a very similar tool. Oh, excuse me. And see, the first thing you do, it'll put a dot in there, and you can vary it. And so this will basically change how this thing looks, and based on the curve. Try going the other way. And this is something you can just play around with. Now notice you get this halo effect. That basically is a sure sign of over processing. So this is basically raising this value. We don't want to do that. If anything, it should be lower. I'm going to change the curve to all kinds of crazy stuff. Try out our best. Now look at that. That produced a nice effect. So maybe we need to ease off on it, include a little bit more of it. But these can be valuable tools just to kind of play with and see how good it can be. The resolution, the graininess, that's not going to go away anytime soon. And the last thing to try is one of those old friends, the contrast and brightness. We can reduce the brightness. Maybe it was a little overexposed or something. There's too much white in everything. And we can bring down the brightness some. I tend to like to go down individual percentage points like this. Contrast, you can always increase contrast. That's going to supposedly add, black content to everything. The contrast is a scary one because things can get weird around the edges. You can see that there's some points starting here too, and that's just a little odd. But overall, we're getting better color than what we had before. The gamma helped, but it's not a miracle cure. And for the life of me, I'm not sure why that thing turned blue. And there's similar tools. We could take this image into Photoshop too, if we save the final. And you can always have fun seeing what we're going to get. Inverse effects. I mean, there's lots of weird stuff you can do that may or may not help your image, but it doesn't hurt to try. Just a little bit of processing. Yeah. I think we'll give this one a break. And then with the way that this thing works, so when you save it, it's like it likes you to do all to apply everything before it. And of course, we want to apply it. But you can see before and after, which is like, well, that's significant. Even though, it started out with a fairly awful image, very fuzzy, very hazy. And I'm just going to put in here, we'll just say for first, for our first try at it. Now that'll add something to the setup. It is not the last one you'll ever do. If you save your raw stack, that original one that came from AutoStacker, then you're good to go. Well, since I've gone for 45 minutes on a crap image, let's try from AutoStacker. Let's try the other Jupiter image, so we don't waste time on this one. We already know that these are pretty close to the same, and they're neither one of them are looking impressive. So we'll get out of there. I think I just need to minimize that, get it out of the way. So the second we're going to bring up is that other Jupiter image, which let's look at details again. And you see we got our two fuzzies in here, and there should be, oh, this is all video formats. So this should be our other one. Same again, 2 minutes worth. We'll open it up. And this one, if you remember, was a little bit better. Same settings as before, and we'll do the analysis. I'll take a second to go through. But you see already this image has got good stripes. It's a little grainy here and there, but that was partially because of the Barlow. And that's the danger of using Barlows. They're not my favorite always, but sometimes it's the only way to really zoom in. And for doing a visual, look at the universe or whatever with the cameras, that's probably a good way to go. We didn't have any alignment problems before. We can try setting it to, more and basically, more, so the size of the access point. So you can see we can get 600 some. We didn't have big problems. But maybe this is a smearing issue, and we can go from there. Um, you'll notice that like over here, when it hits the 50% bar, is a lot further along. So this is probably a pretty decent image. And if we want to say our 15% for Audi, maybe the other one, I mean, this one really doesn't duck below until 75. So we could try 75. We could even try 25 and let it go. For now, let's just try Audi's 15% or, yeah, what is it, 15, 25, 15 would probably be around this line, wherever it crosses that 25 line. So let's leave that alone. We got our access points. We got this stuff set. We're not going to use fuzzy anymore. We're going to use sharper. And that'll identify the file a little bit better. And you can always mess around with dithering or drizzling, sorry, and some of the resample settings. And after a while, trial and error. Some people swear by certain settings. Other things is like this sharpened. That will attempt to do mechanically what Registax is doing with your eyeball and playing around. So I tend not to use that. I got good results initially, but after I discovered how to use Registax, that was kind of the way to go. And keep in mind, these tools are for planetary images only, which means basically all the planets, close-up stuff, the moon. If you happen to pick up comet photos, they can sometimes work there. Comets are a little weird. If you photographed an asteroid, congrats to you. You probably got some kind of satellite camera going. But yeah, let's let this thing go for a sec. Now, I have a lot of fun doing this because I'm a computer guy. So I'm going to check in. Anybody got any questions going on? Because I don't see anything in that live chat question box. But we're still holding on to 11 of you. So you haven't gotten bored and you haven't shot yourself, we don't think. So it's not that boring. I get into this because I'm a computer guy, and this is a way to tinker with stuff and get really great results. And this is really where you're pushing the limits of your camera, your optics, your techniques, even, how you collected these things and what settings you use. That is very, very important. And really can't emphasize that enough. This is taking a while. AutoStacker isn't the most sophisticated tool in the world, but it does such a nice job of stacking that it's really hard to ignore. So let's see what our stacked image, before we hit Registax, let's see what that looks like. So already this almost looks better than what our TIFF file was after we got done with, or where is that? Oh, did I not save it? I didn't save that icky file from before. Oh, here we go. That's the first. So, okay. But you see, this we did have some square edges. I didn't even notice that before. So this is starting out from a lot better place than either one of those two. You can see those are cloudy. Under normal circumstances, if it wasn't demoing, I probably wouldn't even touch those things. Like, that's garbage. I'm not going to get anything out of it. This one is kind of debatable. You see that red spot is still kind of dark, which is a little odd, just a little odd. So let's open that up with Registax. And where's Registax down here? Registax is kind of a flaky program. It really likes to be opened and closed individually each time. And you sort of get that after a while because like, oh God, it's going to do that again. And we'll look for the only 2023 we have here. And that'll bring it in, it'll look at it, and bingo. And here we are. Again, dyadic. If you don't do that, you can play with these settings forever. This linear thing, it doesn't seem to do much of anything. It's just horrible. I once did a live demo in front of my home astronomy club, the University Lowbrows, and I had that setting on there. It's like, I don't know what's going on, guys. And I was going nuts trying to have it do anything. And as it turns out, it was just that setting. It just doesn't do much. And you see our number one setting here isn't going to really, it's not really going to do much for us. We can try pumping this up a little bit. I used to pump these up more regularly, but I found that they don't help that much. 920. I'm going to check my schedule and make sure I don't have any more obligations tonight. I do not. So I am with you guys for the rest of the night. Or until, well, attendance gets to 0 and it's time to call it home. Time to call it a day. Yeah, see, this one isn't really doing much. So let's leave that off. Yeah, 2 again. And I think these are both due to that Barlow usage. If you take these off, these check marks are useful because if you have a setting, it's like, well, it's producing some weird stuff. I'm not sure if the graininess is in this level or another. And you can basically take the check marks on and off for either one, any of those things. Only 3 gives me some results. Yeah, see, this is the other side effect of some of the over sharpening. You get weird creases and other stuff in there. It did seem to help a little bit, but we got to back off until those creases disappear, because those are bad news, and they will carry forward in all the other releases. So, but we might be able to do with maybe increasing this percentage and not going as strong on that one slider. Honestly, I can't tell you what these numbers actually do, but in messing around, see, we've got our slider, our graininess and stuff back there. Yeah, that's going to be too much. So maybe we'll leave 3 around. We'll go to 4 next. And see, that makes a big difference already. You pull that in, maybe increase this size now. Starting to get those creases again. Means it's heavily processed. Let's back off. And if we get some graininess like up in here, that might be a spot to use some denoising. A lot of this is just kind of keeping an eye on your entire image and not overdoing it, not being afraid to back off, because we always got another level we can use that will pull in more detail. But you see right before you though, this detail comes alive. We bump these up maybe to 110, 120. I've had images where I've had to bump it to 180 before, but frankly, never with this camera. This 183 camera is, I don't want to say impervious to that kind of stuff, but it really doesn't. Now see, that's looking pretty reasonable. It's got lots of different colors in the stripes. It's not too terribly over processed. We're only starting to get these things. Maybe adding some denoising on the previous level can help. And oh yeah, we can reduce our blue. Still looking a little lumpy though. That's a little worrisome. Let's back off on that. And let's get rid of that blue. That's just hideous. Yeah, you can see the blue is sticking out big time. So what I might do in the future is to basically start putting on a blue filter on my camera to reduce some of this blue, because it's drowning out all the stuff that we want to keep. Now my Photoshop friend would say, oh my God, this is veering toward the black. And what this is doing is essentially sliding some of these figures over, so it gets rid of the junk noise that is basically from 0 up to this first line. And in this case, we're doing it color by color. So by reducing that blue, you see we get a lot more natural color from Jupiter, because Jupiter it's a big brown hole that I think it's methane that it looks brown. We turn down a little bit of the green. Yeah, blue looks like it's sticking up a little bit there. We can do the alignment. The alignment trick. Let's see, blue channel. We'll move the blue down. And sometimes when you move these things a single pixel, it can brighten up the image and bring out details that you never knew were there, because the layers are basically blurring things for you. So they don't allow the full image to come to light. In this case, I think because of the Barlow, things are coming. But you'll notice that moon is looking more and more distinct. And let's use the zoom feature and look at what's going on with the moon. Can't really tell outright, but to me it looks like there's like a green tinge up here. So I guess that would be putting the red up a pinch. So that green, it turns more into a brown. And that would probably be Io. I'd have to check the Jupiter sites to make sure. And see, blue is still sticking out of this edge here. Blue is just being pesky on this thing. Notice I brightened it up just a pinch. Maybe just a pinch down too. Nope, 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 nope. It takes an eye. And after a while, maybe a little bit left even. Bring that in. Because once the blue combines with the red and green, you're going to get white light, which is kind of what we wanted all to get in the first place. There we go. That's not too bad. And let's bump up that one just a pinch. Maybe a little too much. 7.3. See, these things are buttons too, and I don't know what they do. Registax has got probably some of the worst documentation, and it's one of the most valuable tools. It's positively maddening at times. But you just mess around with the controls and you look for stuff that fixes what you're trying to do. We can look over here and see, even there, that's a lot of blue in that area. There's some tools in Photoshop that we might be able to play around with. Who knows? There's cropping areas and stuff that I just haven't figured out how they work. Sometimes you can mess with the histogram here. You notice we're still getting a lot of blue shift over here. And I think we can separate out the blue and pull that back. Oop. Kind of going the wrong way. You see how that kind of flattens thing and evens out some of the color. Now this is close to I think it's the lines tool in Photoshop. And see, you want to curve they all should sort of match. I mean, they're going to have different shifts depending on what's where, but so this has kind of allowed some of that detail to come through that we fought for in our stacking. This is not a bad image, and given the poor quality of what went into it, I'd almost say this is a keeper. I have to apologize for a little yawning because last night was it was a late night, and frankly, I was worried about all the things that were going to happen today. I'm the secretary of the Great Lakes Association of Astronomy Clubs, GLAC, who puts on Astronomy at the Beach. And in this year, I did a lot of work for arranging all this stuff. And when we had troubles yesterday, it would kind of put me into a tailspin a bit. And so I'm a little paranoid today, but things have worked out much better today. Things run very smoothly, in fact. So we do learn from our errors. And I think we're going to do that. We're going to do all. which this is a fun button to push because it'll basically take you back to the raw and show you what you did. And it's like vast improvement, no matter what bad qualities there might be. That's still a pretty good image. And we've got one of the moons present. So now that we've done a do-all, we can save the image and say this is going to be our good image. Still as TIFF, because if we wanted to, we can take it even further and take it into Photoshop. And I think for now we're going to leave Jupiter alone. We didn't get very good Jupiter pictures, but I'd like to try that moon because I haven't really done a moon shot in quite a while. So that is our set here. I don't recall how many frames. Did it tell us in here? It did not. It would be nice if they told us how many frames that it captured in this session, but no. It did tell us the temperature, which the temperature, if you're taking deep space photography, that can be very handy. Because like I say, the DSO camera that I have, it has a cooler on it. And what you'll find is in like pictures like this, if the camera is too hot and you're taking exposures for longer periods of time, that's going to produce little red, green, and blue dots in various places all over the place. And it's just plain old noise. And I had a picture once and it's like, on screen, on my laptop, which has a fairly awful display to start with, this is displaying really bad noise. And it's like, I looked, it's like, oh, dummy, you didn't turn on the cooler. Well, I turned on the cooler and I did what I did, a stupid thing, and I turned it down to -5 Celsius. It can go down to -35 Celsius, which is generally 35 below ambient temperature. Oh. Excuse me again. But taking it down that fast, you can actually get ice crystals built up on the sensor, which is like, okay, I froze my sensor. A rookie mistake. But if you take it down in 5-degree increments, you did that. The next time I did it, of course, I took it down slowly, and each image that came, and normally the dark image, you're taking it like 30 seconds at a time. So every 30 seconds, there would be a layer of red, green, and blue noise pixels that were simply disappearing. It was turning it back to black or that, super dark blue that you normally see in the sky. And that was like, okay, this is why you pay an extra couple $100 for this camera, because it's got this cooler built in with all the extra parts and control mechanisms. And it made a huge difference. That camera, the 294, is actually a much more, the pixels are almost double the size of the planetary camera here that I'm doing. I'm sitting here yakking and I'm not loading anything. You guys should kill me on that. You're being very nice with no comments or throwing things, and you've kept it at 11 people, so that's terrific. And we're going to shrink the image because we want to see more of it. And this is full resolution too. So that is everything we got. Maybe a little bit more. Anyway, the alignment points, yeah. We can see how it does with that. I thought it scaled this. Oh, I didn't analyze, duh. I got to let it analyze before you do the alignment points. Now in here, the image had 1,400, close to 1,500 points. So there's a lot more points, and the resolution was significantly higher. So here the resolution was 5496 by 3672, which is full resolution of the camera, because the moon simply doesn't fit in the normal camera. So this is going to be a lot more data for it to chew through. And if you recall, the size of the file was larger as well. This was that 57 megabytes. I don't know why they do this. Yeah, 57 meg. So significantly larger than the Jupiter shots. So Jupiter shots we shrunk down. We didn't capture at full resolution. And this, of course, takes a while. My PC is an i3 processor, so I think it's still quad core, but it's a slow thing. It's made for mobility and long battery life, which it does. I can run for 3-4 hours on this thing out in the field. So if I take the laptop and the mount that I have, I can run for probably 2-3 hours capturing, because I'm using the SSD. There's no disk running and no fans and other stuff. So it's pretty energy efficient, which is really great, because you can run, without any electrical wire and run your full imaging setup. Maybe not all night or anything, but for a couple of hours, it's worthwhile. If I replaced it, I'm not sure what I would replace it with, because I mean, in the Apple world, they're turning to AMD, and they're getting serious performance out of them with battery life that's unbelievable. So that might be something to do. But for now, the price is right on this one. The last laptop I had, which in some of those pictures, it was the old Dell. This is an Acer machine. The old Dell machine, it decided just to stop booting one day, which I think the BIOS was shot. I got the data, I got the disk out of the thing and messed with the data, but wow. Sold it for 20 bucks. I liked it because it had a titanium frame. It was very sturdy. It was built like a tank, kind of heavy. This Acer, the screen is real wobbly and all that, which every time you open it, you sort of have to open it from the center and be very careful. And it's not as rugged for outdoor use, but price is right. It's got a seriously long life battery, and the keyboard's a lot better to type on. Not wild about the number pad, but it'll do. One thing I did like about Acers, and in general, the Acers have got a ton of ports. This thing's got, I think, 3 USB ports and a USB-C port, and 2 of the USBs are USB 3, which can run my camera at top speed. So it turns out this was actually a really great laptop to buy. It was very easily to expand the memory, and the SSD literally was, I mean, it was a little card, and it had a screw. You put it in its slot, connected the connector, and screwed the screw to keep it all tight. And that was it. All of a sudden, you've got yourself an SSD. And like I say, I have 1 terabyte SSD, 1 terabyte spinny disk, and that is generally enough storage. But I mean, some of those larger images, when I captured a bunch of planetary stuff when I first got the camera. I was out there for a couple hours. I was just capturing whatever I wanted. Ooh. Turns out I wrote out over 140 gigabytes of raw file. Now I cooked that down, and it was probably 4 or 5 gigabytes of finished files. But my 90 gigabyte backup device is like, this ain't gonna cover it. The Blu-ray discs have been really nice. They're the writing integrity is guaranteed for life, or 1,000 years, whichever comes first. So I figure that's once you write once with that, you're going to be in good shape. Okay, and that was the analysis. And you see, these are all really good quality. So this one, yeah, maybe we'll go with our map. What does it say here? 70, let's say 75%. Which for the moon, that might be a tad high, but I'm not gonna, you know what, I think what I'm going to start doing is just put what the subject is. I should try to get in the habit of doing that because I don't know what half the files are when they get out of their directories. So we'll do the stack, which should take a little less time because it's not doing as much image analysis. And of course, that's going to take another 5 minutes. When I get a new PC, the performance is definitely going to be higher. But it's like auto stacker at Registax. Those are the freebies in the planetary world. There's a program called Deep Space Stacker. Deep Sky Stacker, sorry. And it basically does the same thing. It does alignment, and it takes in light and dark frames, and it does things for your deep space objects. So like, M27 or some nebula, it will take those things in and do all the alignment, do all of the adjustments, and do basically anything you like. And it does a pretty good job for just about everything. But like I said, the image when it had M57 over the top, that made a big difference. And I think I started out showing you some of those images. But that's the kind of thing where it's like paying for a program. It was, you grumble about it, but it actually made a big difference. One of the other good programs is this Fast Stone Image Viewer. There's some formats that Microsoft doesn't read so well, and that program takes care of those things. And it makes a really great browser. You can also do clipping and other quick processes, if you will. 2%. Yeah, this is going to take a while because it's a big image. But this one's worth doing because you see the image quality is already very good in comparison to what we had with Jupiter. And all these craters down here, I purposely took it with some of these things intact because those things are going to jump out at you when it finishes. And it may take a little while. How many we got? We're down to 6. Yeah, you are shrinking. And if we got any questions, let's check. What are the minimum system requirements? Oh, for the system. There really aren't. It's got, I would say running Windows 10 these days is about it, and pack it with lots of memory because all this processing here, it absolutely loves to eat up memory. That's probably what I can, that's probably the nicest thing I can say. All the imaging, get big hard drives, be prepared to move that data off of there when you're done processing because you simply can't afford to keep it around. Some people have done those NAS, the network drives, or striped drives. I think there's some 10 gigabyte drive packs that are out there, or 10 terabytes, sorry. But yeah. Oh, what else can I talk about? Hadn't counted on this taking quite so long. But we can look at some of the other raw images that we went through here last night. I mean, obviously I did Jupiter. Moon's in the wrong place. But Mars, we got some very good shots of. And maybe I shouldn't bother with the moon. See, this is what they the videos and these outside images, the stackers will take care of that problem. That's your low quality image. But in here, you notice we got some surface details shining through. Those are looking real nice. And these are with the Barlows. So the Barlow images, you gain something, but you also get a lot of graininess. So sometimes going without the Barlow is a good idea. It was, I think that, yeah, these two are the good ones. That was the Mars captures. Saturn, I think we had some pretty good ones in Saturn. And these are, like I say, these are the raws. And the raws are not bad. Maybe I should have done Saturn first. Got another Mars in there. Actually, that was a pretty good Mars there. We'll do that, 2301. Somebody make a note of that. 2301, 15. Good Mars image. There we go. Yeah, Gibson's stuff was making a note of the dust and the clouds. I showed that earlier, but that's worth bringing up again. Yeah, this is the current state of things. 20, is that right? No. Yeah, 19, 20, 20, yep, 21. Yeah, that's the cloud situation, and it only gets worse when you start talking about smoke. It's our current smoke map. We just say we're on the edge, but it's going to get worse tonight. You spend a lot of time on this atmospheric program because it can tell you a lot about what's going to happen in the coming days. Like, coming up Sunday, okay, it's going to be great till about 6 o'clock, and it's going to get cloudy. And generally 24 to 48 hours. So this top bar, that's the useful one. These down here tell you generally what's coming up in the week, but I've seen these things where if you get a clear spot and then maybe a day worth of clear spot, it'll shift a day or two either way. So it's really hard to say. One thing, this is kind of an interesting display here on Monday. This is the daytime temperature. And then this is the dew point, which you don't think too much about dew points. I would like to go back to last night. Yeah, Saturday, no. Yeah, it won't show me Friday. But when this dew point touches the temperature, that's when you start to get heavy, almost like a rain, a dew that forms on all of your equipment. So they include this because they want you to keep an eye on that. So that, if you got a dew shield or something like that, and you're out imaging, get the shield on there, cover your stuff, because it's gonna get wet. Like here, 61, it met up in the exact point. And I've been out at night when 11 o'clock or something, that dew point, you reach that and it starts falling below, and you will get absolutely drenched. To the point where you say, gosh, did it rain here? And the answer is no, but it sure looks like that. So that's when the atmospheric, I find it really useful. It can tell you here like when the ISS is going to pass by. So well, yeah, in about, I think here, ISS path, yeah, it'll tell you where it's going to be. 2159. So you can look in the basically the northwest, and it'll be going toward the north, and that's where you'll see it. So if you train your telescope and take a video of that area, and if you can follow it, good luck. Like I say, Brian Autumn's telescope's the only one I've seen that follows it that well. But if you put your telescope in those areas near these stars, you'll see the space station go through. Gives you the sunset and sunrise. Yeah, wind is a little bit here, I guess, as you yeah, I guess, yeah, I'm trying to tell what it doesn't have a very clear, but that's, I guess, lighter is heavier. Is that right? Darker is lighter. I never pay too much attention to wind because I've got an 8-inch telescope and it acts like a kite in anything but a still, anything but a very still light breeze, which is one of the reasons I bought the Ioptron mount, because it's got, you see, it had the telescope on one side and a big heavy weight on a counterweight on the other. So it's very sturdy. It's got 2-inch legs, which they don't go anywhere. But we are making progress on this thing. It'll take another chunk down here, but it is making progress. Some of the other things, I guess we can go through some pictures. Why not? I got to fill a little bit of time while it's processing, because I think the moon is going to be a really spectacular image once we finish it up. These are all the orange can. The case and all that I got is, it seems like a boring topic, but you use this portion, this thing so often. I basically got the Celestron case, the foam wore out. I bought some replacement foam for it. These are actually some surplus scuba equipment cases that they didn't have, the gauges or whatever got corroded, and they threw those out, and they had these empty cases. And we took these things, and you can buy that exact size, you plump it in there, and now I've got a very nice case for all the optics. And I got a similar one for my cameras, which I didn't really show. The cameras I like keeping separate. This image down here is kind of an interesting one. Yeah. Oh, yeah, that kind of gave it away. A Botnoff mask is a funny looking thing. It's got a funny pattern of lines and stripes through it. Part of it is a see-through, part of it is solid. And what it does, if you point it at a bright star, like Vega, for instance, it will produce these diffraction lines here. If you're out of focus, this center line will be, one side or the other center. And when it's in focus, you get this nice symmetric pattern. And if you're doing deep sky and doing star stuff, it doesn't work as well if you're doing planets, because frankly, the forwardmost surface of Jupiter is at one focal point, and if you want to get the edges, you generally have to adjust. So you're always kind of in the middle somewhere with Jupiter. But a Botnoff mask is a fantastic tool, and once you focus with that, it's great. I know SharpCap has a focusing tool that puts a false Botnoff mask in there, but frankly, just having a simple mechanical one you can stick on the end, it really works well. And I think it's like a $15 piece of plastic. It's really dumb, but it's ingenious. Oh yeah, which when you want to see the comet and it's like -16 outside, you don't stay out very long. This is a nice picture. I've got it actually here at home. Um, when I was at my previous job, I worked on both the Cassini and the Rosetta mission. I was building web pages for getting at their data, and they had various servers working. But for when I left the department, because the research funding was running out, they had a copy of the comet, the picture of the comet, and they all signed it for me, that was really special. And I got to get around to hang. I hate hanging pictures. Gretchen will tell you all about it. And this is our experience with the solar eclipse. This is what a thunderstorm looks like in a solar eclipse. But we did get a partial eclipse. I was having a lot of problems with my camera that day. These are just through the eyepiece pictures. And you can't tell anything. But we did have a good time with her great uncle Gil. It was the first time he had seen an eclipse. So how's this thing going? 92. That's doing pretty good. That's that stage, I might add, but we'll look through a few more pictures. These are sunspot pictures. False colors, all of them look like this gray. If you're lucky, you get a little bit of modeling. I did take some solar stuff this afternoon that we can take a look at. This moon is it's taking up too much time. I really should get on with it. Think I should cancel? Any other comments? No. Maybe we'll do a sun picture next, although they're going to be just as large, although I think I only did 2 minutes of those. Good. Coming around. Let's see what it does. I'm hoping the other phases will go a little faster. This is pretty slow. So if anybody wants to contribute toward a new computer so we can see these displays go faster, I'm all for it. I won't object. And this is where it's doing the actual stacking. So after it's done all of its alignment and other features. You know, I hate to cut it off because we've kind of gone so far, but this is going to take all night. I've seen these things take hours, so we're going to cancel this and we'll move on to something more fun. Well, Uranus, I don't know if anybody's ever seen that. This is a SAR file I caught last night of Uranus. And frankly, after stacking and everything else, this is about as good as it gets, but it'll be a little green spot. But this is uncolored. I didn't adjust any of the things on there. That's pretty much what we found. And it was amazing because the telescope actually did that first try too. So, I was at Mars and I was like, let's go see Uranus, and boom, there it was. These do have the Barlow in them, so they're a little fuzzier than they would be, but otherwise it's literally a single green dot. It looks like 3 or 4 pixels or something. Where was that other? The sun. These were the solar pictures. The last one, I think. Yeah, these were, so you can see some of the haze that was going on. Yeah, I think, yeah, that one wasn't bad. But the sun is utterly unimpressive at times. Yeah, these did 2500, and they're probably at full resolution as well. But there's nothing on these to really do. You can pick out one frame and it looks just like the other. The tracking was really great this afternoon. See, I could whisk this along and it makes no difference. Shrinks a little bit of air currents and all that in the way. On the H alpha, we did see some shots with a sunspot that was forming in this region here, I believe. But it's not visible yet in white light, only in the H alpha ranges, which are 658 nanometers, I think. Teeny weeny. What was I going to look? Yeah, that's the sun. I can show you what I got off of Neptune, but like I said, this is a fog-laden little image. You can see it looks very gold. It's not blue at all. It's just horrible. That was very disappointing. I wanted to show folks the Neptune. I think we're going to try Mars, if I'm not mistaken. 21015. What did I say in there? 230115. 23. Oh, they're probably in the Saturn. I'll tell you what, let's correct that. Yeah, those are both Mars. So I forgot to change the location. We'll take care of this problem right now. And then that goes into Mars. Here we go. And they're just down at the bottom. So let's look at 230115 up at the top. I think those were pretty good. Yeah, the Barlow ones are just, they make a big image, but they're not that impressive. I think these have got slightly higher exposure rates. 2318 is pretty good too. Let's do 2301. We'll open it. Get out of the abyss. The moon is impressive, but oh my God, those are so huge. With Mars, you can see the size of the file. is tiny in comparison. Yeah, we need more than that. Yep. There. That's a little better. Neato. 11,000 images. But notice that these images are significantly smaller too. They're not full images. They were 1024 by 768. So they're considerably smaller images because with Mars, there's no point in taking a big image. I'm going to check on Bob for a second here. Well done, Bob. Oh boy, I don't know if Bob is there or not. Nope, that meeting is done. Okay. All done. Okay. Now, I will say right now, Brian Autumn is starting his New Mexico journey. Let's see, we still got 5. Let's see what AutoStacker is doing. 100%, excellent. And see, the quality on here is very good. There's 11,000 images. God, I hope so. And we could try for the maybe the 25%, 75. This will cut down the size of the number. We got 11,000 images, so let me see here. We got Mars. We'll go with that. There we go. Okay, we'll let it stack real quick. What did Bob say? Cool. And you see this is going much, much faster than the moon because the images are just much smaller. This has got a promising look to it, although you can see there's a little bit of graininess here and there. We will see. Actually, let's see. I think there is a. I do have all. Okay. I think there's a way. Analytics. We'll see. Is this thing done? It's getting there. Mars is kind of fun to play with, though. Yeah, welcome to this. This is the time when you kick back and you watch the rerun episodes of Star Trek that you missed the first time around or the second time around and want to re-see them, or you catch up on your DVR viewing while these things are processing. And that's why I say it usually goes a couple of weeks, and a lot of people would gripe about it, but I just like, well, I set this to go. This is my hobby, and I can keep myself busy for another 2 weeks processing stuff. And sometimes, like the live images or the DSO images, they can take, hours, not necessarily to process, but to just tweak and play around and adjust the images and whatnot. It does take time, but it's kind of the other half of the hobby. Capturing and all that is great, but this is how you turn them into real pictures. And I don't want to say it's trivial. It's not trivial, but it's also not rocket science either. Kerbal Space Program, that's rocket science. And there are some videos that Bob did yesterday of the Kerbal Space Program. Highly recommended. It was very popular too. My phone is buzzing at me. I don't know why. Okay. I appreciate all you viewers. If you like what you're seeing, make sure you hit the like button, add comments. Feel free to ask any questions you got. How long does it take 11,000 images? Yeah. The question from Andrew Tudor, how long to take the 11,000 images? I believe that I had that set for 3 minutes. I think max it might be 2 minutes, 2 minutes 30. Not very long. Normally I write some of that stuff down, but I can't remember when I set that to. Sharp cap. I was doing 2 minutes for a long time just because it was a good thing. So it's probably 2 minutes. The frame rate of the camera when you in sharp cap, when you reduce the resolution, those images are smaller, and the smaller the images, the faster you can capture. So it kind of, if you can, like you're doing a small target like a planet, Mars or Jupiter, you get a lot better results if you can make that image small, because you won't have to chew through large images like you see here with Mars. Those images are probably a quarter of the size of what we got with the moon, and this thing is just breezing through. Whereas if you got to chew through those big images, it has to load all that data, has to chew through it, has to do all that stuff. So thank you for that. That's actually a good question. And it depends on the amount of time. Sometimes like a single image that you take in the DSL world, the deep space world, you might spend 30 seconds on one frame of a picture. And those frames, because you're taking only, I think the Eagle Nebula I took, each picture was like 40 seconds long, and I maybe got 60, 70 pictures, 60, 70 frames for the entire imaging session, which it turned out to be about 40 minutes. It was kind of crazy. Because sometimes, like, well, this is a glitch, or we had a cloud move on, I have to pause the system for a while. The DSO technique is a lot different than planetary, and people like both. One, and some people like one or the other. They're like, I ain't gonna bother with planetary because it's such a pain. It's like, well, it's a different set of tools. Often the software is much different. How you treat the images is dramatically different. So I learned on a very small camera, which if you look on the solar session, I got out the small one. It's a little $150 camera. It's I'm going to put it down. It's a ZWO ASI 120 MC2, which now is USB 2. And that was, like I say, that right now I think those go for about $150. And they're great cameras in the sense that the chip is very small. I think it's like a ½ inch or something diagonally. But even though they're small, that can take great pictures. So in my my photos here, the planetary, these Jupiter pictures here were taken with that $150 camera. And you say they look pretty good. Yeah, they're kind of grainy because there's not much resolution there. That one, yeah, it's over processed there. But those are not bad for a cheapy camera. I think this might have been a 185, which is like a step up, like a $200 camera. But still, those are good images. And I had fun pushing the camera to its absolute limits. And sometimes that's one of those things I like doing is like, okay, I've got this stuff. I'm going to make the most I can out of this situation. And that's why I don't mind. Like I've got an altazimuth mount, and everybody says, well, for deep space, you really ought to be taking, you really ought to be doing an equatorial mount. But when I'm getting images that are like this for the wrong kind of mount, I don't think I did any of the flats, darks, or things you're supposed to do. And this, yeah, this was 131 frames at 20 seconds apiece. So it's like if I can do that with my rig, and you can do the math on 20 seconds. So, okay, that was probably, maybe 15, 20 minutes worth of process capturing. But it got the color in the stars. None of the stars are smeared. They're all nice and round. So it's like I have fun pushing my equipment that I have as far as I can. You can save money. These are some images I did with different techniques. This is a raw one. This was using one tool, which you can see it kind of has there's like a blank ring, a dark ring around the thing. It was a little odd. And this one was I think it's Astro Flat Pro, or maybe this is one with the ring. But I compared the two, and I did an article for our club newspaper, or club newsletter. And this was the raw that it started out. This is typically what you'll get in the deep space world, is you'll get all this kind of fog, and you can see the telescope is here and it's projecting on a flat surface. So you're getting some stars, but out here you can see you get a little bit of streaking, a little bit of that. So generally, I don't worry about those. This is the output of AstroPixel processor, APP, and you can kind of tell because it's made for doing mosaics, and this is one of the things where it basically equalizes all the images. So typically, you'll get this. This is a raw stack. You do a cropping of this thing and then continue on with your processing, either in Photoshop or using APP's tools, which are pretty good. I've gotten good results out of those, but I've gotten better out of the Photoshop. So I think this was the native tools in AstroPixel processor, whereas this is what I got out of Photoshop. So frankly, some of these cloudy regions here, APP just never picked up on. But that's okay. For being an all-in-one, this is my masterpiece, I have to say. I captured the Veil Nebula, and these are such fine wisps, and to catch that on my type of telescope in Ypsilanti, which is like light pollution central, that was pretty amazing. Good, our Mars stack is done. You've listened to me blather on long enough. And so here is our stacked image, which, if you remember, like, we're not quite done yet, but this looks pretty good. I'm going to bring this up in the Oh, cast to device, open with, here we go. This Faststone image program is pretty nice. If it ever comes up, there we go. So it gives you a nice view, and I think you can zoom in, which isn't going to show us anything immediately, but it gives you some idea. There's some surface detail. There's got the polar cap on there. This is going to be a good image. So, and we can bring that TIFF up in Registax. Next, you know the drill by now. And we'll go out to Mars. And here, because it's the native resolution, we should have a little better result. Again, dyadic. And we can see what we get. I'm going to put the zoom view in here, actually. That'll show us a little better effect of what's going on the image itself. Yeah, there we go. So know whether we've gone too far. See, already we're starting to get a little grainy stuff in there. So, but notice it did something on one, whereas the other ones don't. Come on, there we go. And you see, that just made things come alive. That's great. That's going to be a good sign. Maybe we bump that up, see what we get different, if anything. Yeah, maybe a pinch more. It's not bad. You add a little bit of noise suppression to it. The denoising is always kind of the opposite of sharpening. So sometimes you add a little bit more sharpening. When one notch of denoising, it can get you a long way. So based on this, we got 12.2. So maybe we'll start out at 3 or 4 and see what we get. Notice that brought out some of the darker features. There we go. A little better contrast. Let's pump that number up a pinch. See if that helps a little bit. That's looking real nice. So right now that's looking nice. We're not getting any grainies that I can see. Greenies, not grannies. And so we'll go with 4, but notice 11. We don't want to go much more than that. Now that brings out a lot of contrast in these light areas, and that's going to be troublesome later on. So I'm going to back that one off just a pinch. But it does, boy, it really does clarify these details down in here. So we're going to, this might be one of our better Mars images, guys. You are witnessing history. I've had some pretty bad Mars images, so I'm excited that it's coming to opposition because we're going to get some really great pictures out of this. See, we're starting to get, so it gets very bright, but you'll notice I didn't get any of the red or blue craziness that I got with Jupiter. The moon will turn out well, and I might just post it to the Orange Can Astronomy page, which I think I'm going to put that in the comment section there for you. Do the stacking rotates automatically for Earth? The stacking itself does not. But see yeah, actually, yeah, this is Andrew's question. The stacking, you're basically your mount is compensating for the Earth moving. And so that's why, and when I talk about the rotation, it's not the rotation of Earth, it's rotation of the planets themselves. Jupiter, for instance, is rotating at 9 hours per rotation, whereas we got Earth at 24. So there's a mathematical equation that you can work out the differences and what the rotational speed is, but it amounts that you can only capture about 3 minutes worth. Mars is roughly the same as Earth, but you can't capture for longer than an hour, and the thing is going to move because my telescope is stationary on Earth, and it's aligned based on my latitude and longitude on Earth. As you go by, you're going to have different angles as Mars travels across the sky. And of course, different lensing. It'll actually appear larger when it's shooting through more atmosphere, like the sun gets bigger at sundown. So the rotation isn't really for that. Now my tracking will track the object across the sky. But the big difference is if you have an equatorial mount, those are aligned so that the equatorial mount is rotating the same as the Earth is on its axis. So the axis of the telescope mount is the same angle and declination and all that as the Earth's axis, and that's why you polar align your scope. So that way, when the mount is moving around, it's moving in parallel with the Earth. Whereas with my mount, because I'm aligned based on my position on the planet, my camera and my mount has to move up and down in all the different directions, and you end up getting strange angles. Now, with that said, if you're only capturing a couple of minutes worth, it ain't going to make any difference at all. And that's why they're used typically more for planetary work than the deep sky. Whereas the deep sky is like, I'm going to have to do this for like 5-6 hours, and that thing's going to travel across the sky, and the angle is going to change greatly. So that's why deep sky is usually an equatorial mount thing, but it doesn't have anything to do with the rotation of the Earth for the stacking. The stacking is basically your time slice. And in planetary, that's a 2-minute time slice, and the angular differences are so minor that you won't see it. I hope that answers the question. And I was going to give out the, I think it's AS. It's facebook.com, and it's Orange Can Astronomy. I think that's the URL. It looks happy. That's where most of the pages or the other images I have and some of the other stuff I've done. Get that out there just so you can see what's going on. Let's go back to Registax since that was, there we go. Since that was looking so nice. So 110 actually brought out some really nice stuff here. And then we're going to play with this a little bit. But see this, it sort of lightened it up. It didn't really add anything to the image. And you see how it's kind of turning neon? It's just getting gross. And this is only at 5.4, so it's really low. We pull that back. Sometimes the 6 doesn't do any good at all. Sometimes I don't want it to wash out the other detail that I've got. So I kind of like that better, even though it's negative, which is interesting. Usually don't go negative. But it's an interesting way to show off that detail if we're going to get that effect. Then we can pump that. Now look what that did. All of a sudden we've got a little halo around here. Uh-oh, that's a bummer. So let's pull that down. I wonder if going to say 90 would help us or hurt us. Lots of possibilities here. But that is a darn good image. There's a little bit of a halo, I can tell, but frankly, it's negligible, and I like the results of the planet. It's like we got details in here and whatnot. Now, here's the fun trick. Let's do all. Boom, that's what we started with. And it's going to go through the entire image and process that for us. And that's what we ended up with. I think this is the best Mars image to date, to tell you the truth. This is really nice. So what I'm going to do is save it, of course. And we're going to call that best for right now. And that will be good. I will post that. I'm going to crop off the excess because this is a bunch of dark space. You don't need to look at that. That's really spectacular. I like that. So yeah, I'm glad we moved past the moon. We got more questions. Yes, thank you. Good. Hopefully that answers some questions. If anybody's got anything, please, now's the time to ask about this stuff. I didn't check how many people we still got. The few, the proud, the 3. I don't care. I'm having fun with it. Hopefully you guys are too. Make sure you fill out the survey at the AATB 2020 site, basically where you navigate it in. They've got buttons all over the place to take the survey. They really interested in what you liked and what you didn't like, if there's improvements you can make or things that you thought were really great that we should bring back next year. I will say a little bit about that. We did this as a COVID response to go online, and we haven't gotten the final attendance rates or viewership, whatever you want to call it in the online world. But we have gotten extraordinary response to some of the telescopes in New Mexico. We had a great response to David Levy's talk. All the headliners actually got good responses too. So we had teaching panels that were engaging. We had trivia sections in the kid thing that lasted for a long time. Went over an hour and messed up our schedule, but we were glad to have the interest. So if there's, I think we'll probably end up having an online component next year, even if we have to go, we go back to in-person, which the in-person stuff is fabulous. Don't get me wrong. Having 70 telescopes, perhaps some 22 or 16-inch telescopes out there to look through and see this detailed galaxies and stuff with your naked eye. It raises the hair on your arms, but it'll be worth it. But I think there will be an online component. We haven't really decided anything. We're still trying to get through tonight. This is kind of toward the end of things here, but we'll go with that. And I might even do a blog once in a while, just prepare one of these things and put it out there for people to do. Let's see, what else did we have to look through? I know we had some other Mars images that looked, that were supposed to look decent. We can try one of the Barlow images. I'm getting a little down on the Barlow just because all it is a bunch of grainy junk. I don't think it's worth the effort. I get a lot better stuff without it. Yeah, this was the good one. I think this is, oops. Seems to me this was a pretty good one. We can look at that movie. Yeah, the air last night was kind of jumbly at times. But you see every now and then it clears up and the view is really fantastic. And that's why you take that 15% or 25 as I did last time. And that's why Ani does that. Yeah, this one was only 285 frames. A little higher resolution than what we had before, but that might also be with the Barlow, who knows? I don't know why this reverses. That's the dumbest thing. Let's do a Saturn. Saturn is always fun. You got to see Saturn at least once. Let's find a good image. That's one without the Barlow. This is with the Barlow. Let's do one without. We can always crop the thing, because Saturn is ultimately impressive. I'm really glad that you guys saw what the difference the Mars could make, because that really is that's what makes it. Yeah, I think this is the first one. We'll see in a second. It's going to be super small. Let's do the analysis. I got about 7,000 images, but the images are relatively small. And I've just taken, it's going a little slow, but it's not too bad. Basically, the stacking is one of those, it's a lucky strategy. And you hope if you take a lot of frames, then statistically, if say 10 or 15% are good, then you've taken some great frames and you can toss out the rest that you don't care about. So out of 7,000, we'll maybe keep what is that about 760, 70, 700. If we even do 10%, who knows? But that's the reason you take a gazillion frames. Is you're just playing the odds and the statistics. this doesn't look too bad. We might be able to let this go. Anything else going on around? Let's check for more questions from you folks. Any more, Andrew? We're getting good questions from you. Yeah. What about me? Yeah, a little telescope history. I don't have pictures of everything, I think, but I started out with one of those department store telescopes, a little 60 millimeter, I think it was, refractor. The lenses were garbage. The objective lenses were garbage. It was a $100 telescope. But it got me hooked when I saw Saturn. If you see Saturn with your naked eye and you see the rings, and it's mesmerizing. Jupiter, unfortunately, isn't nearly as so, because through the naked eye, it just looks like brown. You see a couple of lines, some of the cloud lines, and of course the red spot. But Saturn is just magical. Oh, excuse me. So I reluctantly, that was a gift, an anniversary gift for my wife. She wanted, like, well, if you're going to be staying up late, why don't you do something productive? And got me that thing. And I sheepishly went to her. It's like, well, dear, I hope you don't mind, but I'd like to sell the telescope. And he says, why? I thought you were really enjoying it. I was like, well, I was. That's an 8-inch. Yeah, to go back, answer Andrew's question. The aperture is an 8-inch, which I think it amounts to, is it 1200 millimeters or something like that? You can figure out the math. But it originally was part of a Nexstar 8SE. So it had the original mount and everything, which I have some pictures I can show you there of the thing. And I don't really want to say anything bad about the SE mount. Well, this is first light with it. Oops. Oh, there we go. Yeah, I did want to. So we'll move it around. It's basically tripod. There's a center thing here, and it's got these little bolts. There's 3 of them that screw in from the bottom and screw it down. So the mount itself mounts up real solid. It's a single arm, but the arm's real heavy, and generally it holds it pretty well. But unfortunately, the 8-inch this is a 12-pound scope, and if you got a 12 pounds on one arm, if you get any kind of wind, you will notice that it shakes a little bit. And frankly, the gears in here, I don't want to disparage it, but I think it's the declination gear. It basically goes bad early, and once they go bad, repairing them is expensive, almost as much as the mount itself. So mine, it slipped once in a while, and it's like, well, I start reading, and it's like, yeah, this is going to come on, and I'd rather sell it while it had some life in it still and let somebody do something with it. And I basically took the optical tube here and got a different mount for it. And that mount, that's the iOptron I'm using right now, and it's very sturdy. It more than can handle the 12-pound weight, plus the cameras. It's got a counterweight, so everything's balanced. It's really quite nice. It's more than what I paid. It's as much as I paid for the original telescope. An 8SE now runs 1200, just like it did when I bought them. And that gives you the mount, the computerized handset, the whole kit and caboodle. It's a go-to setup. The iOptron mount was as much as the telescope in the mount. So you'd pay a little bit more, but like I've got 2-inch legs instead of 1.5 inches. It's little things like that that make it so much more still when you're trying to take a picture. So, and it looks like auto staggered is done. That was that the analysis? Yeah, that was the analysis. So let's look in here. I don't even know where Saturn went. It's got to be over here somewhere. Oh, there it is. So what did I have? 115 APs. Is that 16? 56. Now let's go with 16. And then we'll stack. that didn't really take too long. I can jabber on forever with telescopes, but that's the first one. Um, well, I should probably back up. After I had the a refractor, I went to I ended up talking to my wife, and I got an 8-inch Dobsonian mount. It was a Newtonian telescope, which is the two mirror setup, and the views on it were very good. Probably a little better than this SCT. And we call that the sewer pipe because it literally looked like a big black piece of sewer pipe with one end that you looked into. That was good, but I found out that I don't know my stars very well, and heard some rumors that if you have a smaller telescope, it won't pick up as much light pollution. And that is 100% correct. However, it also doesn't pick up quite as much light, which is the stuff that you're looking for. But I bought a Nexstar 4. That was that telescope. I didn't replace the 8-inch completely, but I tended to take the 4 because it was so portable. And frankly, I still miss the 4 for being that portable. It was a very nice little telescope. And right after that, I was gifted the department chair where we were both astronomy buddies, and he was going to be moving back to Bristol, England. And he gave me a 12-inch Meade LX200, completely motorized and computerized. It was a huge, complex thing. I think the telescope weighed about 75 pounds. The tripod was this monstrous 3-inch legs. They were huge. The tripod weighed 50 pounds. And when he asked me, well, he's like, well, you want it? It's like, well, yeah, I'll take it, whatever. And the first thing he asked me after that was like, well, what car do you drive? What? What do you mean, what car do I drive? I'm going to take your telescope. It's no problem. Well, it turns out that was a good question because the telescope did indeed fit in my car, but I had to put it in the back seat because it was too big to fit in the trunk. The tripod legs and all were just heavy, and I finally got a car that did fit it, a Chevy Impala. But that telescope was so heavy and so cumbersome and complex to use. I was up at my father-in-law's place, this place, one night, and I spent all night. I couldn't get the focuser to work. I couldn't get the alignment to work. I mean, I was just having trouble after trouble. And I was grumbling the next day. I don't think I have any pictures of that. Grumbling about it the next day, and I noticed in the astronomy magazine that there were going to be sunspots out. It's like, okay, great. I grabbed the 4-inch, got it set up, and I put the solar filter on there, and I was looking at stuff in about 10 or 15 minutes tops. And he comes out, I showed him the sun, and he says, well, you know what? It's like, clearly you do well on this telescope. What you need to do is sell both of these, buy a telescope that's sized in between both of them and works like the 4-inch. And well, he was exactly right, because the best telescope you get is the one you use. You've heard that before, I'm sure. So I sold both of those, and the proceeds went to basically the cost of this Nexstar 8. And I've had that ever since. The SCTs are great telescopes, but they do have limitations. They're excellent planet killers, they call them, because frankly, they pull stuff in like you wouldn't believe. So like taking pictures of Mars or Saturn or whatever, boy, that doesn't look as nice. Oh, it's still working on it. Because they're ideally suited for relatively stable things. Going for those, they have a very narrow field of view, which is the problem. And going for the deep space objects, if that's small enough, that's great. But otherwise, you're going to have to basically take cookie cutter shots of the sky and then use a program like, say, AstroPixel Processor to stitch them all together and stack them and do all the particulars there. So that was a problem with the SCT. Now you can one of the images I had on there before was it used what they call a focal reducer, and it basically changes your f10 8-inch SCT into an f6.3. The lower the focal number, the faster it is, and the shorter duration photographs you can take. And likewise, if you want to take, say, a 2-minute exposure, you put one of these things on and you only have to take, say, 30, 40 seconds, which, hey, that's about all my mount can take. So working with a focal reducer, that allows me to shorten the time that I would normally get. So maybe if I take a 30-second picture, I can collect the same light as if I took, say, a 2-minute picture with an equatorial mount, with a faster telescope or something, or a slower telescope. So it just allows you a little more flexibility in the timing and makes it faster. Now there's a product out called a Hyperstar that will turn your scope into an f2 or 2.5, something like that, which would be great for taking deep sky. But with both of those products, whether it's a focal reducer or the Hyperstar, when you get the outside fields, you're going to have more distortion there, smearing of stars, all kinds of other things. And you get those with the short tube refractors and stuff too. So they have extra sets of lenses to avoid some of that problem, but they do have that issue, even though they're much faster and you can take very long duration photos in no time. But that's one of those downsides. Oh. But the SCT, the Schmidt-Cassegrain design is kind of it's a compromise on all fronts, but it does a great job. And I just realized I have Mars in the name. I didn't change that to Saturn. Oh well. It is making some progress, and it's faster than what we were getting on the moon. So I'm going to get out of here. I did save that image, didn't I? You guys were watching. So delighted that, yes, I did. Best at TIFF. Good. And now you can bring it into any program that will support TIFF, which is just about everything. If there's any extra cleanup or cropping you got to do, which I guess I could do that now, although it'll slow down. All I want to do is crop it. We'll open it with Fastone. That's the best. So this one. There. That's the view I wanted. But they have a crop view, which is nice. So we can basically crop this thing down. And the beauty of it is, you can pick a standard size, which probably is a good idea. There we go, 25%. And paper ratio crop to file. And it will remember this, and you can basically go from file to file and crop. So you've got a whole set from the same thing. You can crop it. I'll just say crop it. So now we have a file that is a fraction of the size, but contains the same data. So if you want to look at it, close up, but it's a nice little program. I'm real happy with it. I think, yes, I do want to save the changes. Best, and I always, this is common practice. Everybody adds extensions, and we just say cropped. So it's cropped, and notice that now I have 3 files in that directory, best and cropped. And see, the crop, they naturally want to scale up and make it look nice. Oh, I almost forgot I got to export it. And I got out of there already. That was dumb. Yeah. Where's Fastone? There we go. But it also remembers where you were. Let's see, file. Save as. and what we can do, because Facebook and other places don't want any part of that. We can change it to PNG. 24-bit, blah, 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 options. New file size. Yeah, it shrinks it a little bit. So now we have a PNG, which we can post on our famous Orange Can Astronomy page. Yeah, I did get the URL right. That's good. I didn't remember where I wanted to go. Just lovely. Anybody like this new version? I really hate the new version of Facebook. It completely doesn't do anything for me. And you'll notice I had a finals directory, and this is the cropped version. September 26th, astronomy at the beach. Mars taken last night. Taken at Friday. Astronomy. See. Word. You won't believe how many times I've typed this in the last week or two here. And yeah, you can see how much action's going on now. We'll put that in there. So now we'll have a nice post. You guys witnessed it. You were the first to see it before the rest of the world got a chance at it. But yeah, that was a good Mars picture. I'm happy with that. And normally I don't post directly there immediately, but it turned out so well right off the bat that I'm not going to complain. And you can see normally we get pretty good response on this page. Lots of people reached. Nice review. This is the new finder I got, actually. It's like a laser. It is a laser finder, but it puts some concentric circles in the viewfinder instead of just a single red dot, so it doesn't cover up what you're trying to view, which is it was pretty stupid. But yeah, this is what things look like at night. It's kind of a ridiculous thing, and you can see my neighborhood is not it is not a dark place by any means, but we're pointing up, so it doesn't seem to mind, and I'm dealing with the cameras, the computers, and all that, so it's not so bad. Yeah, there we go. Yeah, well, it'll give you an idea of the site anyway. Let's see if this thing is finished up yet. 89%. Yeah, we're almost there. Okay, news Facebook seems slow. I noticed the computer runs. It likes to run on the Microsoft Edge. Yeah, I'm using Chrome actually. I have a Chromebook and I use Chrome on Windows and Mac. So I have tried the Edge browser. I probably should try it after they've released it now, but I'll leave it at that. I was going to say the new Facebook. I think the problem, and this is totally off topic, but see here in a group, I've got, well, probably half to 2/3 of the screen taken up by stuff that doesn't have anything to do with what I really want to read, which is this little small column over here. And it's worse if you go to, say, the home. Now I've got, probably half the page or more that's taken up with junk that I don't care about. Oh, this is my wife's big project. Yes, we are Michigan alumni. Can you guess? And that's not a Sigma. But it's the Facebook is taken up here, and the vertical spacing is atrocious. It's like, am I reading like a vision impaired version or something? The use of space is just terrible. It doesn't look unpleasant at the offset, but it's just not very usable. So that's my diatribe into Facebook. I'll leave it at that. Yeah, and I will say the Chromebook, I originally bought it because it can run Android apps for the bands that I'm in. I'm doing all my music is now digitized and on the Chromebook, so that there's an Android app called Mobile Sheets, I believe, Mobile Sheets Pro, something like that, and it's made for displaying music. And the Chromebook I found. It was a Chromebook 13, and it basically is a 13-inch screen. It's a hybrid, so I can use that as a laptop or a tablet. And in tablet mode, it basically shuts off the keyboard. And it turns out that little machine, it probably has 8 hours or more of battery life. It does web browsing and all that really easy, and all of my Chrome bookmarks sync between all of my devices. I never have to mess with that at all. I know other browsers do that, but this is just, I'm just thrilled with it. It does work really well. I don't even know what this little 35 active contacts. Okay, I've got 30 people online that know me. That means 30 people will probably throw stuff at me at some point. See how this thing is doing. Yeah, it's almost done. So 43%, it'll inch forward, and then we'll see what Saturn looks like after it's been stacked. See, these actually look pretty good. These are, if you recall, this is now blown up. It zoomed up to 130%. So when that gets back down, and once it comes back, this will be a nice picture. And I think we'll get something out of it as well. You never know until you try, you know? Wow, I had that open this whole time. Yeah, with a stupid, wow, what's that? That's strange. I didn't think we did any Saturn. It's still processing. I don't know why that is there. That is so strange. But let's cut out of Facebook. We don't need that anymore. Yeah, you three are quite loyal. I thank you. And you've put in your likes. That's excellent. No, it's a good thing. And again, if you got any comments, somebody seems to be answering me. Andrew is holding on for dear life. Maybe he's the only one, and people just keep ducking in. And I was like, "What is this fool talking about?" Well, Andrew, actually, do you do imaging, Andrew? Or are you just looking to get into it? Trying to keep my throat from getting dried out. Oh, look at that. Well, yeah, that probably takes extra. I was just looking at the image in my upper right-hand corner here, and it's like, oh, look at that. I got my boring green background. Normally, I have some kind of nice image on the back. And, well, usually one of the nice images that I've done. It's really fun. You go into business meetings. Currently enjoying observing with a Meade refractor. Nothing wrong with a Meade refractor. It's good quality glass that they're putting in there. Is that with 1 1/4 inch pieces? So if you got 1 1/4, you're kind of golden. Then you can put just about any of these cameras on there, and you could do it fairly cheaply for like $150 or something. Some of the under like the 0.96 or whatever, those could get a little dicey, and they vary hugely in the quality. But if you're getting a Meade, I would suspect you probably have the 1 1/4s. It means you could stick anything in there. Which I should bring up imaging. Yeah, this is the ZWO site. If you look at planetary cameras, and I'm not trying to sell anybody anything. It really doesn't matter to me. But like say for $150, this is what I had when I started out, and it's just it's a nice little camera. It doesn't cost a whole lot of money. You can find out whether you can do anything with it, but you learn a whole lot about how to do things. Yeah, this is now up to better resolution and 60 frames a second. Yeah, you're good. That's a nice starter camera. And if you're not sure if you really want to do all this work to get images, that's a way to do it. There we go. For eyepieces, I found it was from Orion Telescopes, and it was their brand, and I think they had a 32 and a 40 millimeter, a 32 and a 40 millimeter eyepiece, and they were relatively wide view. I don't think they'd classify as truly wide view, but the 40 or the 32 that I have is my favorite eyepiece, and I think it's. I've gotten very good deals on that from them. I mean, they have sales on eyepieces and stuff. I got my 32 for, I think it was like $56. I don't know if it's a closeout. I have no idea. Good. We are done imaging or stacking. So now that it's all named Mars, when it's really not. This is our finished image, which it's hard to tell if it's done anything. Notice the blue again. This is going to come to haunt us. Let's bring up Faststone again. That'll allow us to zoom in a little bit. Uses traditional controls, which is kind of a pain. But we can zoom in a little bit. And see, we got a little ring separation going on there. I think we can have some fun with this one. Let's take a look at it with Registax here. Even though it's got Mars in the name, we don't care about that. We can fix that soon enough. Yeah, Saturn. I don't know how in the world we brought up that other image. Oops, sorry. I saw the image. That's what I wanted to click on. What's the problem? So here, again, we're going to view zoomed. And Saturn, because it's further away. And you always have to worry about the edges of these rings. They can be a royal pain. With here, I'm just holding the control key down. And you see it looks a little overexposed. And that might be true. We could probably turn down the brightness right now and save ourselves a lot of hassle. And just taking some of that off, that helps it immediately. You see some of the cloud layers are starting to come through. Doesn't look quite as overexposed. There we go. That came down a lot. And Saturn is a fairly dim thing. But see, if we start out with it a little dimmer, that'll help us in the long run. So let's see what we get with our first. I tend to doubt much other than, yeah, a bunch of grainy shit. Okay. Let's just forget about the first one. I'm not sure if this was taken with a Barlow or not. I honestly can't remember. And by the looks of it, maybe not. I don't think this is going to be any good either. It's too fine. Oh, look what I did. You guys didn't catch me. Dyadic. Boom. Look at that. Wow. So let's see if 2 did anything. A little bit of something. That's too much though. Yeah, look at that. That brightened up. Not sure if 1 is going to do anything or not. Sometimes it can, but you can see this is nice. The sun is basically hitting it almost directly on. So this is almost at opposition. I wouldn't say opposition is there. We need a little bit of noise control here because we're getting kind of some gritty looking stuff here. But overall, this is looking very nice. You saw it here. Okay, good. Just keeping an eye on your comments to make sure I'm not missing anything. Sometimes it helps just to do it all if there's some screen redrawing it doesn't do perfectly. Yeah, look at that. That's very nice. Pulling in some details early on. I don't think 1 is doing much of anything. Yeah, I can't tell. Excuse me. Oh, I thought the cat came by. If you happen to see a very fuzzy gray and white cat come by, that's Loki. He is our little boy. Oh, that kind of blew it out fast, didn't it? Let's ease up on that a pinch. Now, I've noticed the 4th wavelet, it can get out of hand really fast. So you got to be very careful with it. I'm going to add a little noise, denoising to all these levels. But I mean, just Saturn is, I mean, just that's just mesmerizing. I'm sorry, I'm a Saturn freak. We'll do 3 of that. You see how that blew out the rings? All the detail went away. And that's only at 3. Reduce that some. But we got good separation here. Usually that's hard to get in this, I forget what they call that now. It's not Cassini gap, but there's a name for the gap. And see, if we're already at 1.8 here, doing anything at this level, we could try bumping it up there. That can help. But you know, let's get our balance under control because we still got a lot more blue. Now notice this is catching a lot more wider area of the histogram. So I know Saturn isn't got that much blue, so let's tame that down a little bit. Because Saturn is another one of those ruddy gas giant planets. And maybe pull down the green a little bit. Maybe a little bit more in the green. Not too much. Let's pull some red. We already noticed the problem. We've got blue issues. Every time you bring down red or green and only have blue, then you change the relative. I think that still green is a little bit high. But this stuff in here is generally considered noise, so let's do it all. That should, let's just start looking pretty good. That's not bad at all. Once again, we took some good images last night. Just didn't realize it. Yeah, histogram's not bad. I think we're going to pull down that blue one more notch. See, we're still getting some blue in between here. And I'm pretty sure I've seen Hubble photos, and I don't recall Saturn being blue at all. That's still got some graininess in it. Try denoising it. The skies were kind of hazy last night, so like some of the cloud detail in here I've gotten before with my telescope, and tonight I'm not, or last night I really didn't see that. Even though this processing is going really well. And I will say the planetary stuff, I usually don't have to take it into Photoshop. Most of the time, Photoshop I use just simply for labeling, putting a watermark or whatever on, saying, who I was and what parameters were in there. That's one thing people like to see on the images. That's the first question they ask, is what were the parameters when you took it? Which then you can go back and say, well, it was, and you start rattling off this stuff, and after their ears bleed, you can you can save. They won't ever ask you that ever again. Here, the gain was even pretty reasonable too. 252. It's a pinch high, but Saturn is a lot dimmer, so you'll end up with a little bit higher gain setting on that one sometimes. But it is looking, that's a nice picture. And what is it doing? Oh, it's test switching. Yeah, it's times like that. It's like, no, don't go away. I don't want to do this all over again. I make it look easy. I'm glad you think that, Andrew. It's a lot of trial and error, and you shouldn't ever get discouraged. And if you have an issue, I think I don't know if I put my email in there, but email me a copy of it. Heck, I don't care. Here's my email. You may have found yourself a new buddy. Well, for benefit of everyone else who can't hear immediately. Basically, if you're patient and you're willing to deal with the details, then you'll get results. And it does take a little experience to know, because I mean, the first time you do it, you're going to be all over the map, and don't get discouraged. We can always pull that kind of stuff together, or work with you again. These days, screenshots and all that, or screen sharing, it does miracles. I mean, we could use a Zoom session or something like that, and work through the thing together. I'm more than happy to do that. Ooh. Really apologize for the yawning. I was a nervous wreck last night and thinking about all kinds of things that could go wrong today. So I did not sleep as well as I should have, as you can see. But yeah, that looks really nice. I'm very happy with that. The do-alls are fun though, just see what it started out with and what we ended up with. And I don't think the RGB is off hardly at all. I'm going to leave that one alone. I don't think we need to mess with it. And gamma, I think it's going to be fine too. I'm gonna say that one's done. Do a save, and we will correct. This is not Mars, it's Saturn. And I don't know if this is the best. Usually I'll spend all week and do all of the ones that I did, but for now, this is the best probably of the season, actually. That looks really nice. And yeah, let's see, Mars. That's the stacked, and this is the best. So what we're going to do is go into our crop tool, and we'll say, what's 25% look like? That looks about right. That's much better. And how do we save that? There's a way to save. It's just that. Yeah, here we go. And I guess we can always change the type right now. It'll save us a step later. There we go. And where's that Facebook page? Did I leave that up? Of course not. Ah, well. Astronomy. Do I have orange sites? You'd think I'd have my own site on here. Nope. Okay. Guess what? It's going to be there. Orange Can Astronomy. There we go. Yeah, I keep all my bookmarks categorized so I can find stuff easy and quick. And I think I'm gonna just add a photo. Desktop captures 25 Saturn cropped. Open. And we did Saturn. Those both turned out really well. I'm glad you guys could see the success, because I've demoed this stuff often enough where it's like it doesn't always turn out. I'm gonna put this as an official comment though. There we go. So now I'm going to bookmark, if I can, blogs. More. Under astronomy, sites, and let's get rid of all this Facebook crap, because we don't care about Facebook. There we go. So now my astronomy links actually have my own site. We'll move that to the top because that's a good site. Yeah, those look really nice. And these are proper orientation. I finally looked it up and determined that my camera, and if we go to Sharp Cap, I can show you the setting. The camera actually you can automatically flip it horizontally or vertically or both. And I figured out that if I put a camera with the connector going out to the right, perpendicular, that you can, yeah, where is it? Flipping size, camera imaging. Oh, testing image controls. How about that? Nope. Pre-processing. Nope. Of course, I can't find anything in here because I don't have the camera connected. Oh well. Anyway, there's a thing you can flip the image on certain occasions. This is also a neat program. This is SharpCap. It's completely professional. I mean, you can have plugins that your, like my USB focuser can connect into here. My actual scope can connect up into here when it works. Doesn't always work. And it's got this neat feature called Live Stack up here, where if you saw Don Switek's session on Friday, and I would go looking for it. It's called EAA, and it's using SharpCap, what we have here, and it's called electronic assisted astronomy. And what it'll do is basically build a deep sky image like this, one shot at a time, and stack it on the fly. And it basically stores all the frames out into a directory like we had before. So you got a directory of 2 gazillion files, but you can see approximately what you're going to get out of this thing immediately. And like that Eagle Nebula thing I showed before, that was done with the live stacking feature of SharpCap here. And so in the course of like 30 minutes, you can see your final image almost blossoming before your eyes. And it's, I mean, tremendously self-satisfying to see, positive reinforcement, all that stuff, to see your image come to life in front of you. And you can always take those images that it's storing away in that directory and then do post-processing just like what we've done here. But you can also save whatever you've got on the screen and as your final, if you'd like. It turns not to do anything but stacking. So some of the finer points of Photoshop or APP, you'll still have to work on it, but you can get like 80-90% there with just that tool, and it's just amazing. For the deep sky stuff, I almost am going to use that exclusively. Right now I have a problem getting my mount to connect up and talk. I might have to take it out of the case and play with it a little bit this coming couple of weeks, because as we see from Astrospheric, it's going to be cloudy quite a bit the next week. So I have some testing time ahead of me. Just fact of life. There's lots of trial and error in this crazy hobby. You're still cracking me up with that comment. You make it look so easy. And all of it's trial and error. You find out what works, and you try to tell people, but then the next image, maybe it doesn't work quite like way, and you learn a little bit about how the light works and how you use SharpCap. There's always a new feature in SharpCap. I was showing Don, the expert EAA guy, about that. It's what they call area of interest or region of interest, ROI. And I showed him that. It's like, well, now you don't have to take full resolution images. You can shrink it down, or tie into whatever you want. And like, wow, that's great. I didn't know you could do that. But he's got the EAA tools have all kinds of things to vary, like how much you want to see here, like a display. So if you're trying to emphasize a certain thing, you can vary the display, or get rid of darks and shift everything over. Sometimes you got a lot of noise, light pollution. You can pull that light pollution over and then cut it off before it gets bad. Lots of things like that. And this is just for the display. There's another whole thing that shows up at the bottom for doing live stacking. And I just started getting into it. I don't have the hang of it, so I wouldn't presume to try to demo it like Don did, but it works really well, and I'm pretty pleased. What else has this thing got in it? It does lots of effects. You've got a built-in histogram you can look at. So this looks probably very similar in way here. If you go logarithmic, that'll look kind of similar. You can see. This doesn't let you play with the thing the way the other one does. And I think, oh, this is the focus assistant, which I honestly have not figured out. I have to read through the documentation. The guy that makes the program, who is it? It's a funny name. Oh, that's Sharp Cap. Robin Glover. There we go. My friend Don there. He worked with Robin developing Sharp Cap, and so he's gotten like a beta copy for years. But it's really he's a great guy. Don is, and this program is solid. It generally doesn't crash at all. It just works, which is great. There's another program out called Fire Capture, which I don't remember if I have on here or not. Let's icon a few things here. And wow, I got a lot of junk open. How'd that happen? I guess this is Ostrostag. Okay. Maybe I tossed it. Fire Capture is got another feature which I think SharpCap probably has. Yeah, I'm not seeing it here. It doesn't like my cameras as well, but it has a feature where if you have a picture of like the moon or something sitting up there, excuse me, you can basically put a little rectangle around this region. It's like, and tell it to like keep this region where you're at. Or keep the telescope pointed at that region, and it will adjust the telescope and track that feature as you go around. So your telescope always is moving with things. What was this? Solar Live View. I think this was a program for masking out portions of the sun. So if you're taking a solar picture, you can mess with that. I think this is SkyTrack, right? Yeah. This is kind of a neat little program. Free trial has expired. Yeah, okay. I think that's a normal, but this one is made for tracking satellites. But it turns out it will do ISS trends. It can do solar system objects. And the neat thing is, like, it knows the date, so it will tell you when things are going to be there. I've got some things programmed for where I'm at and what obstructions I see, and it will tell you, it's like, tonight, these are the objects that you'll be able to see, which is really cool. Different stars, things like that, Mars and Neptune right now, because at this time of night, Jupiter and Saturn have already set. You can't see them. So, they're giving you some hints about what you should go see, and it will connect to your telescope. See the ioptron stuff here. And if it connects to the mount, then you can basically say, I'm going to go to that. Boom. And off it goes. So it's a really cool little program, and you can do your slewing and all that manually right in here, or type in a position, whatever. But that was a pretty cool thing. I can't remember. There was somewhere. Oh, yeah. This is where you put in southern. I can put in basically how high I've got trees at both my northwest and northeast corners, but I do have a small open spot directly north. So that's what's kind of driving its collection. If you're going to be blocked at certain degrees high, it'll adjust its list of stuff here for what you'll be able to see, which is great. It also tells you, time of day, all that kind of stuff. But yeah, SkyTrack was, it says it's not registered. I can't remember how much the thing costs. Help, is that in there? Quick reference getting started. Available update. Okay. I'll do that while I'm thinking about it. But it is a good program. I've used it before, and if nothing else, use it as what to look for. So there's a ton of free software. I think there's probably a session or two that Adrian um, did on Stellarium. And Stellarium, if you use it with Stellarium Scope, so this is why I have them ordered this way. Ioptron Commander will control my telescope. Stellarium Scope will connect to Ioptron Commander. And once you have Stellarium Scope, you can launch Stellarium, which has special configs to talk to your telescope, etc. And Stellarium, if you've never seen it, we'll just call it up real quick. It's a slow program. And I think I'm going to get rid of Registax here because that's gonna crash soon anyway. Registax has got a buggy quality to it. And I didn't actually start Stellarium. There we go. But it's a planetarium program, but it's got some neat features in it that allow you to control your hardware and stuff. So if you've got hardware that it knows about. So what it said before, like it knows time and date, where I'm at, all that kind of stuff. So Saturn and Jupiter are both pretty low. It gives you this, some days about where things are. I like it because it can show you, it can show you what things are going to look like in your scope. So if we find Jupiter and Saturn, wow, what the heck did that do? So here in Jupiter and Saturn, we can zoom in a little bit. And so this is what my camera will see if I'm looking that way. And so this is the Pro. If I get out the 183, are you really going to do that every time? That's so annoying. That's my object. And now I can choose the telescope. If there's any special lenses like a 2x Barlow or perhaps the focal reducer, you can get an idea of what that's going to look like with a focal reducer versus not having it. So you see how it makes the window smaller. And so if I have a deep space object that's covering a lot of territory, then yeah, that's going to be a lot better thing to capture more territory with. So this helps me kind of scale, like, well, is it worthwhile trying to catch that object? One of the things I was looking at as well with my southern view, there's really not a lot you can look at some days. Let's turn on the. So there, Santa's, wild duck, eagle. I think it was one of these NGCs. This is the Milky Way that goes through here. That's why it's kind of dense. Omega Nebula. So, well, this is one of the I showed for the Eagle Nebula. And it's like, I can now zoom in and it's like, okay, this will fit in my camera. If I change back to the 294, so the 294, this will easily fit within that camera. But say, if I went out to look at, well, whatever this blob is. Well, actually, Andromeda. The moon, well, yeah, actually the moon is valid too. See, in the 294, with the focal reducer, the moon will fit. If I use even none, I don't fit the whole moon in there, like you see. So if I want to fit the whole moon, get the focal reducer out. Boom, you've got the whole thing. And you don't have to worry about it because there's nothing around the edges that you have to do. So, I mean, Stellarium's kind of a neat program in that way, but It's also good if you want to, track around the sky. Northern Triads, Triangulum, Andromedus. Here's the Andromeda Galaxy, which is one of the largest galaxies because it's very close to us. And you can see, even with the focal reducer, I cannot fit this thing in my telescope view because it extends that far out. So the best I can get is a piece of it, which if we want to get out, which I'm going to get out because it sucks down a ton of time, I can get out my pictures again and show you that DSO picture. I'll show you the Andromeda Galaxy, and it's not that impressive because you can't see it all. Well, that was I had vignetting issues before I knew about the program, but you see, this is only a portion of it. It extends out, and it's bigger than the moon in size. Hence our stellarium issues there. So stellarium is actually a great program just for browsing through the sky. And a lot of times, part of astronomy is getting used to cataloging, and it's like having a plan of action when you go out, and because your time is limited outdoors, either freeze to death, or you run out of time because in the summer you don't have that much nighttime time actually. There was a night this summer. I started out, I think it must have been, well, it was just getting dark dusk, so it was near 9:30, 10 o'clock, and Don and I were having such a good time, and then the sky was so clear and so wonderful. Ended up staying up, and I think he finally got off the line at around 4:30 in the morning. And I was going to town. I was imaging all kinds of stuff, having a ball, and I went to go get Uranus, and I missed Uranus because the sun was coming up. I couldn't believe it. It was so annoying. It was like, what? I'm losing my darkness already. So I packed everything up and I made it indoors by 6 o'clock in the morning and get a shower because I got bug spray and stuff all over me, and uh, crawl into bed. And my wife says, like, what, did you go to the bathroom? You just getting in? It's like, no, I am just hitting the sack now. I need a couple hours of sleep. But it was a spectacular evening, and I think I chewed on data on that thing for 2 weeks. I collected so much planetary, and I think it was close to like 140, 150 gigs worth of stuff I collected that night. So, and the crowd is increasing. That's amazing. Um, and just to go out to you people who just joined us, please use your like button and leave comments. Ask any questions you want. Oh my God. Mosquitos, yes. I hate them. I hate them. They're little vampires. I don't know where you're from, Andrew, but do you have mosquitoes where you are? Because ours are pretty fierce at times. The last couple of weeks they've been awful. Yeah, I'll get that out from. It won't let me move. Oh, there's the window. We from thermocell. It's actually a butane unit. The thermocell unit puts little cartridges of bad stuff that keep the mosquitoes away. And it's fired by butane. You just fire it up and it clears like a 15-foot area. They're really terrific. I won't go outside without them anymore. I've got a belt buckle or a belt side one that hunters will like to use. And I've got one that just sits on a tabletop. And between the two of them, it's like they're fabulous. We got a million refills, and you can sit outside at night and not worry about it. So we're pretty happy with that product. I don't know where to buy them. I found it on Amazon. And of course, fill out the survey at the Astronomy at the Beach site. You don't want to miss that one. Oh, White Lake. Yeah, Mosquito Haven. I had a friend that lived at White Lake for a while. I don't recall which end of it was actually, but it was the swampy mosquito land area at a house that he was renting on the lake someplace. He had a boat and all that, so it worked out for him. He was house sitting for a bit. Yeah, I'm just going to show the folks here what we came up with. I'll use here. Since you're late coming, the new people looking, this is our Saturn image that we processed our way through, and it turned out wonderful. It really did. We also came up with a very nice Mars, and I wish they would show me detail. There we go. Oh, crop PNG. This is the Mars image. And we got good detail. There's some sandy rifts here and all that. The ice cap on the bottom, which I did notice this is shrunk from earlier this summer. So it's obviously heading into a more summery time in Mars. Yeah, and well, we did try a Jupiter, but frankly, this was about as good as we got with the Jupiter. This is the best image we could coax out of it. And even that is, it's okay. Jupiter was it was kind of on the low side when I caught it out, and it was very hazy when I started out. So it didn't turn out as well as we had hoped. Isn't that right, Andrew? Those are the three for today. We got some a moon image. Neptune was complete garbage. I can show you in these were all processing stuff from last night, actually. So I figured that'd be a nice segue since we can't look at stuff. These are some solar images, which this here is the natural color of my solar filter. It just turns up a gray, and this is live action video, and this is as exciting as the sun has been. We were in a solar minimum, so it really doesn't come up. But there is some activity. There was some turbulence or whatever, and you could see where a sunspot could form. And for a while, there was a very small dot that was like a cooler region. So those they can turn out, and when we get back to a solar maximum or whatever year, those are going to look nicer. I liked, actually, I messed with the colors a little bit in Sharp Cap and came up with this, which I thought was a nice natural color image for the sun, especially when it's setting. It gets that little bit of an orange. But again, wow, you've taken a picture of a cue ball. Big deal. People who don't know what they're looking at are not amazed, but I have taken some pictures. I'll show them again for posterity here. These are some of the DSOs. That was the Ring Nebula, which didn't turn out bad, but that's a rehash. These are all taken with that 8-inch telescope I got, so that one's probably the most amazing one that I've caught. I have some friends with equatorial scopes that it's like, I can't believe you got that with your scope. You make me sick. Like, it's just trial and error, and you get it. This was good because the twins, or the towers of creation, are there. This is the Eagle Nebula M16. I try to do this with all my images, is put basically all the stats up there, usually in orange, because, well, orange Can Astronomy. That shows up good against the black background. But try to put that info in there, and it kind of labels the image so other people can't use it as easily. And this was the Omega Nebula, which turned out much better. It seems like I got a better picture of this, or maybe it was a different nebula, but some of this region in here, I had to use Photoshop to pull it out. There is a blue region that's in this area here, but with a big donut-y type thing. I couldn't get much, and I did have a dust donut in this area. But little things like the twinkly stars, that effect is pure Photoshop tools, but it adds so much to the picture. I've done it with and without, and with is definitely better. Yeah, this was as best as the AstroPixel processor could do with the Omega. And you see it got grainy. the blue didn't turn out well. The dust devil was making a mess, and this is more detail technically, but it doesn't look appealing. It just doesn't look that nice. So, yeah, I was going to show the sun. This is the surface of the sun. If you take it, when the thing is at maximum, and the camera is adjusted to see some of the sunspots, you can pick up some of the structure here, which normally, like, the sunspot's going to look more like this, but you zoom in and you stack it and you play with it, you can sometimes get that. But I've found that difficult. This is another one you see right there. Actually, this is a great example. These things here, that's a dust donut, that's a dust donut. Or if you get a piece of dust on your sensor itself, it will produce optical effects. And there's a technique called taking a flat image, which is basically putting a t-shirt over the edge of your telescope and putting a light source on top of there, and you adjust the level so that these things show up, and then you take a picture of that, and you can actually subtract those from your main image, so you can get rid of this junk because it's junk. So those are some things, and of course, I labeled this and whatnot. I actually I looked up the numbers sometimes. This is a great Jupiter image. It looks better when it's small though. But see, the spots is orange. The ones we got last night, they were all blue, which is strange. This is a pretty good image actually. But you see the cloud layers. This is on a nice clear night, and probably without the Barlow. Now I look at it, I'm going to stop using the Barlow so much because it really doesn't help anything. A Barlow is basically a magnifier, and every time you use a magnifier, you have to push more light through it. And with these Saturn, ugh, Jupiter is less of a problem, but you can also overexpose easy. This might be one of the nicer Jupiter pictures I've taken too. There's lots of different cloud layers. There's a hexagonal shape, I believe, that's up top. It just captured a whole bunch of features. And I think that's one of the moons, but it might be an artifact. I don't know. I take a lot of pictures, the same thing. I'm getting a little tired. This was a cool shot because I caught the moons right at the edge. That was kind of neat. There is, is that the picture? Well, I've got several pictures like that, but I know I got it someplace. It was a nice picture, and it had a shadow of one of the moons. This is the one. This is the moon, which is in our side of the sun, and it's casting a shadow onto Jupiter. And I managed to catch that one night. That was really fabulous. That was a good night. And the funny thing was, and this is hysterical almost, is that shadow I never noticed while I was looking through the eyepiece, scoping things out. I didn't notice in the raw images that came through, but once I processed it, got these details out, all of a sudden it was very obvious that I had a moon and a shadow in there. It was incredible. That's why you take pictures is like I got these files here, a SAR file. Okay, I got that thing. It's like if I process it, I might have some hidden surprise in there, and you never know. It's like Christmas. And like I said, Neptune I got one shot of, but it's pretty awful because I had fog on my lens. And well, Uranus. It's never a bad time to look at Uranus. For those folks who are newcomers in here, this is Uranus, and it is with the Barlow, but without the Barlow, it has no shape. It's just a green dot. And it is actually this funny teal color, teal green. You see the skies were pretty turbulent. It's just tossing up the image all over the place. But yeah, without the Barlow, it looks like maybe a pixel or two in the sky. But The the go-to mount found it. We were looking at Mars, and it's like, well, let's look at Uranus. And I slewed over to the thing, and bam, right in the center. It was like I was just impressed. I was like, yeah, I love this telescope. I love the mount. The telescope you can put on anything. So if I might get a solar scope at some point, or maybe a refractor, but that mount is going to be sticking around for a while, I think. But who we got left here? The hardcore people are left. That's what it is. Oops. Yeah, overprocessed Saturn. Big time. And we still got 5. 4 concurrently, something like that. That's great. Any questions from you newcomers? I mean, Andrew has been kind of keeping us busy with questions here. I think we only got one that didn't come from him. Yeah, it's Gibson stuff. And my wife. This is Gretchen. She pinched in and asked a question, being a nice advocate. So it's nice. What haven't I talked about? Good Lord. But yeah, Uranus is pretty special. I do have pictures of Neptune, though. This is technically the whole image, but I shrunk it down and gave you just that. That's Neptune, what I was expecting to see last night, but it didn't show up that way. And that is stacked and massaged over, but it is the actual stacked image of Neptune, which is currently our furthest planet away. You can't see any moons, although, well, I shouldn't say that. One of the moons is up here, which probably is Triton. It's the only one that's bright enough to actually see. I forgot about that. Yeah, but it was a good night. It was one of those dream nights where everything was perfectly still, nothing else showed up, and I've been after to catch all the planets I can, and Neptune was on that list, and I never found it. I'd found it visually a couple of times and confirmed it, but never actually caught up with anything. So I was glad to see it. I do have an image of Uranus that isn't nearly as good as what I caught Friday, which is not bad. If you zoom in, you can see that there's, and this isn't letting me zoom in, but if you zoom in, there's a slight spherical quality to it. My wife makes fun of me. It's like, great, you've taken a picture of a small green dot. Congratulations. But the significance of it. But you can see some of these other Mars shots, they're not bad, but what we shot today was, that was fabulous. This is probably the best one to date. And this was taken, I think, in July, if I'm not mistaken. Okay, August. So roughly a month. And you see how big that ice cap was a month ago. And what we took tonight is a fraction of that. Where'd that go? That was Mars. And where's the best cropped? Yeah. So that's what we took. That's what we took last night versus, or there we go. It did it. Windows does this all the time. Drives me nuts. But you see, this is just a tiny little speck, whereas this was a lot greater image. There we go. That's not bad. You see, I didn't figure out the flipping horizontal and vertical on my telescope or my camera. But the detail on here is a lot sharper last night than it was over here. So that's a great comparison, actually. Maybe I should flip it and get the orientations correct. Plus, this is a little more natural. And I will say, I don't know the size on these things, but over the next probably 2 weeks, Mars is going to continue to get bigger and brighter. It's reaching its opposition mid-October, and it will be the absolute brightest, and it will be brighter than Jupiter. by mid-October. And Jupiter's pretty darn bright. So you'll see that just fine. And frankly, if I get a chance to get out with a scope, yeah, I'm going to take pictures of Mars. And even, throughout October, I think it'll probably be good. But as the weather gets cooler, then it's less fun to stay out for hours at a time, and frostbite and other stuff creep in. There's been nights when I had one night when I was out, it was 75 degrees out. I was watching Mars, strangely enough. And I had a great view with the Dob, but with the Dobsonian mount, you have to keep moving the thing all the time. And even though I was out there, it was 75 degrees. I started in shorts and a t-shirt. I ended up having to go in and put on long pants, like a jeans, and I came out with a jacket because I was freezing to death in 78 and 75 degree weather. But I thought about it later, and of course, your body is supposed to be 97, 98 degrees, and you've got a 20-degree difference. And I mean, wear hats, jackets, anything you can to keep the heat in. Even though it's 75 degrees out, you can freeze to death. And I experienced it. That was weird. Very, very weird. And I don't know how you get rid of this effect. You just do that, maximize it. I have no idea. Windows is so freaky sometimes. Yes, I'm a Mac person. Sorry. It's like you get it near the edges and it wants to do weird things. It is getting toward midnight here. I was planning on just shutting down at midnight because frankly, I'm starting to lose my voice. Talking to you great people about everything from mosquitoes to freezing to death to the weather. And let's yeah, see, right now it's completely cloudy out. What do we got? 46%, completely cloudy, below average, blah, blah, blah. And it's windy, great. But it's still 70 degrees, which is great. Still not reaching that dew point. But you see, that's going to get within a degree. And by, looks like about 4 or 5 in the morning, it's going to get pretty wet out there if you're out with a telescope. So not recommended. Oh, wait a minute, that's Sunday. We're over here. It's still bad. Sunday's going to be worse. And it looks like throughout the week, it's going to be a fairly cloudy week. Not much astronomy going to go on, but maybe it looks like Tuesday could be brightening up. If you go out very late on Monday night, next Monday night. Ugh. What was the other thing? Oh yeah, I was going to look at the smoke. This has got a map layer feature. And if you didn't have this astrospheric, I can put that on the little chat thing as well here. That way it's stored for perpetuity. But it's a tremendously great website. And they do have, yeah, we're in the middle of the smoke right now. It's a total mess. If it wasn't for the clouds, the smoke would get you. I've seen smoke was bad about 2 weeks ago. And it was bad enough where Jupiter, I could barely make out that it was there. And Jupiter, your naked eye is like, oh, that's the bright thing up there. I couldn't see it hardly at all. It was crazy. But yeah, that's a great site for astronomy. They've got a way you can pay or contribute or whatever they're calling it today, and get access. You can save it. It helps them out. I think Subspace, yeah, it's mostly them posting. It wasn't really, they wanted to do a bloggy type thing to tie into your thing, but it really didn't work that well. Yeah. But if you do a login, then it'll save your locations and a few other handy things, which is nice. So I've got, our favorite locations. The Detour Village is up in the Upper Peninsula, up in, yeah, where is it? Right there, at the end of the tip of the Upper Peninsula of Michigan. We go there actually for freighter watching in between the Christmas and New Year holidays. It's right before everything ices over. So you can often get really great pictures, very close up. Like we're talking 100 yards away, these huge freighters are coming through. And you get icebreakers, people get stuck in the ice, and there's I think it's called boat Boat Watch or Boat Nerd, I think, and you can actually watch the boats go through and plan. Oh, this one's coming down, from Nebish Island, blah blah blah. So if you're a Michigander, that's something you can do. You can also do the same thing in Port Huron, watch the boats come through at the last of the season or any time of the season, really. Once the ice forms on the lakes, then yeah, they can't really go anywhere. But it is a lot of fun. I don't know if we're going to go up this year or not. I don't really know. We've done it for so many years, like, well, maybe we should take a break from it. We'll see. We'll see. But yeah, this is the smoke conditions, and I think it doesn't really get better for a while. You get a little bit of a break here. So what is that? Yeah, okay. By looks like Sunday afternoon, it might give up a little bit, but now next week, yeah, it's going to be. This should be a great weekend here for some viewing. In between the smoke, and then later, I mean, that's clear skies, which is great. So hopefully you guys have found great information. And I gave out the email earlier. Please feel free to email me on any of this stuff. I love helping people. It's a great hobby. I'll give it the email again just in case. I'd be more than willing to help anybody with any questions or things they've got. We'll make it happen one way or another to help you out. I just have too much fun not to share it, so I have a lot of fun with it. So with that, we'll see what we got left. And yeah, now we're heading up to record attendance. Great, just when I'm about to shut down. But anyway, I've really enjoyed it. Make sure you do your likes, fill out any comments you have on good stuff or bad stuff we did. And of course, go to the Astronomy at the Beach website. I'm going to pull that up. And they'll have places to take your survey. This thing is coming up. So this big Take Our Survey thing here, make sure you do that. It really helps us out for planning for next season. And I'll put that URL in there too. We've been trying to collect more information. It's like what we did, good and bad. This year was the first season, the first time in 20 years of this event, that they've had to do it anything online at all besides publicity. So for a first try at all this, we think we're going to get final stats. We'll start collecting them tomorrow and whatnot, but we think it'll be worthwhile to do some component of this, even if we do it in person. And like I say, if you check out the past programs of Astronomy at the Beach in their gallery, those are from past years. They did last year we had over 75 telescopes in people in the telescope field for people to look through, and of all sizes, types. If you wanted to go shopping and you wanted to see what a telescope did and all that kind of thing, this is a great place to do it. When we went there, we happened to position ourselves right outside the tent where the presentations were. So when people wanted to see stuff, they immediately came and visited us. So we had a line of about 30 people to see Jupiter or Saturn for the entire night, from probably 7:30 when it got dark, all the way to about 11:30, 11:45 when my battery went dead. And we just had to tell people, I got no juice and you got to go somewhere else. But we made sure that everybody saw, what we intended them to see. We had a little step ladder with a handle so they could hold onto that instead of touching the telescope. I imagine in these days of COVID, more stuff like that will probably have to be done. Maybe shields around the telescope so you don't get all this stuff, with the vapor and whatnot. Face masks, I'm sure, will be mandatory. But in person, it's going to be up to the state and see what they do. So we hope everything will be good. And with that, I think we're hitting midnight, and I am going to shut down now. I appreciate everybody who showed up. All, well, it looks like 7 of you. At one time, it looks like we had, what, 16? 17 was peak. That's great. For me, that's almost a record. So that was doing well. I just got noticed that Brian Autumn in New Mexico, he had 127 people at his. Uh, well, visitors total, I guess current. But we've got lots of playbacks here. All of the materials for Astronomy at the Beach this year, both days, are in YouTube. Um, I'm going to work through them and make sure they've got all the proper keywords for the content and things that are there. Um, uh, if you can go to the GLAP website that we put here, the Astronomy at the Beach website, and you'll see the same index. We're going to keep that up probably for a year or more. And that's basically an official index to everything that happened. Even the ones that are like with the Ford Club, they did their own licensing and YouTube work, but those are all indexed through there. The Michigan Science Center has got the same issues. So you can see everything that you could at the festival or event here. You can see it tomorrow if you like. So with that, I'm going to thank you one more time. Make sure you do the likes, fill out any comments you want, and make sure you visit the survey. We'd love to hear from you, good, bad, or otherwise. It's all going to be constructive criticism. We're going to have a debriefing in a couple of days, and or well, I guess next week. And we'll be discussing everything that we can get. So if you can get the surveys in there, that'll help us decide what's best for the next year. So with that, I am going to say goodbye, and I appreciated all your stuff. I hope I answered some questions and had some things going for you. And I guess we'll call it a night. Have a great week, everybody, and thank you for coming to Astronomy at the Beach, and especially the Orange Can. I have a ball.